Hello there, and welcome to Life Beyond Seen, where curiosity finds a quiet corner and science slows down enough for you to breathe. Tonight we're leaving the surface behind, both literally and in spirit, because we're going somewhere sunlight cannot follow, somewhere few eyes have seen, and even fewer truly understand. Before we begin, I'd like to know where you're listening from tonight. Are you somewhere near the coast, or perhaps miles inland where the sea feels more like an idea than a place? Maybe it's late, the room is dim, and the only waves around you are the soft ones in your mind. Wherever you are, I'm glad you're here. If this gentle dive into the unknown helps you unwind, or if it simply gives you a peaceful thought to drift on, I'd be grateful if you left a like, or maybe subscribed, so more curious minds might find their way here too. Now, settle in, slow your breathing, and let's begin our descent. Because somewhere far below the reach of light lies a place we call the midnight zone. When people picture the ocean, they often imagine something bright and blue, sunlight shimmering on the surface, fish darting through coral, the kind of water you might see in travel ads. That's not wrong, but it's barely a fraction of what's out there. The ocean is vast beyond comprehension, and most of it doesn't look anything like that glittering postcard scene. It's darker, colder, heavier, and stranger. The truth is, the ocean we know is only the skin of a planet whose real depths remain hidden. If the Earth were an apple, everything humans have ever swum through, fished in or photographed would barely scratch the wax of its surface. The rest of it, the interior of that blue sphere, is a darkness so deep it might as well be another world entirely. Scientists divide the ocean into zones, not just to label it, but to make sense of what changes as you go deeper. Near the top, the sunlight penetrates just enough for photosynthesis to happen, which is why coral reefs and most marine life thrive there. Below that, light fades quickly, turning the water dim, greenish, and then grey. Keep going past about 200 meters, and you enter the twilight zone, where the last threads of sunlight struggle before dissolving entirely. That descent continues until about 1,000 meters down, where the ocean becomes utterly black. That's the midnight zone. It stretches from roughly a kilometer deep to around 4 kilometers, and beyond that lies the abyssal plain, which is as foreboding as its name suggests. But even among these layers, the midnight zone stands apart. It's not simply dark. It's a place where light ceases to exist as a concept. No sunrise, no sunset, no stars, no shadows, just perpetual night. The pressure down there is hard to imagine. On the surface, the air presses against you at about 14 pounds per square inch, which doesn't feel like much because your body's adapted to it. But for every 10 meters you descend underwater, that pressure increases by another atmosphere. By the time you reach the midnight zone, the water above you exerts more than 1,000 times the pressure you feel at sea level. To put it another way, it's like balancing the weight of 50 jumbo jets on your shoulders. It's not just uncomfortable, it's lethal. The hull of a submarine must be engineered with an almost obsessive precision to survive those forces, because one small flaw, a bubble in the metal, a weak weld, a single hairline crack, can mean total collapse. Down there, mistakes don't fail gradually. They fail catastrophically, instantly and completely. And yet, life exists there. That alone is astonishing. Creatures that would explode or freeze or suffocate under normal conditions have adapted to call the midnight zone home. They move slowly, conserving energy, using bioluminescence not to see, but to communicate, to hunt, or to lure. Some have transparent bodies, others are red or black because those colours vanish most easily in darkness. Many have evolved in isolation for so long that their forms look alien, but we'll reach them later. For now, it's worth staying with the thought that this entire world, this enormous section of our own planet, is still largely beyond our reach. We can touch it only briefly through steel, cameras and robots that tremble as they go. Humanity has landed people on the moon more often than it has sent anyone to the deepest parts of the sea. When you stand on the shore and look out, the ocean seems infinite. You can't see the bottom, and you can't see the other side. But the real strangeness begins when you start thinking vertically instead of horizontally. The sea isn't a flat expanse, it's a vast volume, a column of liquid that stretches farther down than the tallest mountains stretch upward. If you could place Mount Everest underwater, its peak would still be more than 2 kilometers beneath the surface before it touched the seafloor of the deepest trenches. And that's the part we can barely explore. The deeper you go, the more everything about physics, engineering and biology changes. Materials compress, electronics misbehave, sound travels differently. Even time itself feels altered when measured in the slow pulse of submersible lights and the rhythm of sonar pings echoing through darkness. When early oceanographers first began trying to measure depth, they had no modern tools. They used weighted ropes and lead lines, dropping them overboard and waiting for a faint thud as the weight hit bottom. It was crude, slow and prone to error, but it was all they had. In the late 19th century, when expeditions like the HMS Challenger sailed the oceans, they brought back the first real data about the ocean floor. The Challenger's soundings revealed depths that shocked the world, far deeper than anyone expected, sometimes more than 8,000 meters. Those early numbers were the first whispers of the midnight zone, proof that vast regions of the Earth lay hidden below the reach of light and human presence. Today we have sonar, satellites and remote vehicles that can map the seafloor with far more accuracy. Yet even now, less than a quarter of the ocean floor has been charted in detail. The rest remains a blur of suggestion and shadow. It's one of the great ironies of modern science that we have detailed maps of Mars, of its craters and canyons, but we do not have equivalent maps of our own planet's seafloor. The reason is simple. It's not that we haven't tried. It's that the ocean resists us. Water absorbs and scatters signals, light can't reach far, and radio waves die almost instantly. Even sound, which travels better underwater, bends and distorts over distance. Every measurement we take is a compromise between resolution and range. The midnight zone keeps its secrets, because the environment itself swallows our instruments whole. When people imagine exploring the deep, they often think of sleek submarines gliding silently through black water, shining beams of light on strange creatures. The reality is less cinematic. The few manned submersibles capable of reaching the midnight zone are cramped, cold, and often terrifyingly isolated. The descent takes hours. Outside the tiny window there's nothing but darkness, then drifting snow made of dead plankton and particles slowly falling from the surface. It's called marine snow, and it's the ocean's quiet snowfall of decay. By the time you reach 1,000 meters, the last trace of daylight has vanished. The cabin groans under pressure. The light from your instruments is the only illumination for miles, and if something goes wrong, there's no swimming to safety, no surfacing in time. The sea above is too heavy, too vast. Yet for all its danger, the descent has a strange calm to it. Scientists who've gone down describe a feeling of leaving not just the surface, but the entire world behind. It's not like flying or hiking or spaceflight. It's slower, quieter, almost meditative. The sound of the sub's hull creaking becomes a kind of heartbeat, a reminder that physics itself is pressing against you from every direction. Even the pilot's voice seems muted, as though the water outside is absorbing not only light but sound and time as well. By the time the vehicle settles on the seafloor, you're sitting in a world of absolute blackness, punctuated only by whatever faint life stirs nearby. It's beautiful, but also profoundly alien. Most people never think about what lies under the ocean because it feels separate from everyday life. But in truth, the ocean governs almost everything. Climate, weather, oxygen levels, even the shape of continents. The midnight zone is part of that system. Its cold waters influence global currents, acting like slow rivers that carry heat and nutrients across the planet. Carbon from the surface sinks down there and becomes trapped for centuries, part of what scientists call the biological pump. In a way, the midnight zone helps balance the entire atmosphere above it. Without it, the planet's climate would spin out of control, so even though we can't see it or touch it, the midnight zone quietly shapes the world we live in. And yet, despite all that importance, we can barely reach it. The obstacles aren't just technical, but conceptual. To explore it properly, we'd have to rethink how we build machines, how we gather data, even how we define exploration itself. Down there, every meter costs effort, every observation comes at the expense of risk, and every success is temporary. The sea doesn't preserve human presence, it erases it. Submersibles corrode, cables snap, batteries die. Even the strongest metals succumb to fatigue after repeated dives. It's like trying to build a laboratory on the surface of Jupiter, only wetter and more relentless. Still, we try. Humans have always been drawn to what resists them. There's something irresistible about the unknown, something that makes us keep peering over the edge. But in the case of the Midnight Zone, our fascination has always been mixed with caution. We know it exists. We've seen glimpses through cameras and sensors, but to truly inhabit it, even briefly, requires an understanding that pushes the limits of what materials and biology can endure. Every successful mission to the deep is both a triumph and a reminder that we're guests in a place not built for us. Imagine standing at the edge of the ocean at night, the tide rolling in under a dark sky. The surface seems infinite, but below that calm lies a column of water stretching down for miles, pressing harder and harder until it becomes almost solid. Somewhere in that darkness, life flickers in colours no human eye can see. Machines hum softly, and currents drift like slow winds. That's the world we're about to explore. But to understand why we can't truly explore it, not yet, not fully, we have to start by understanding what it really is, and what happens when light finally surrenders to depth. When light leaves the ocean, it doesn't vanish all at once. It retreats slowly, folding itself layer by layer into the deep, until what remains is not darkness, but the memory of brightness fading. The boundary between the world of light and the world of dark isn't a sharp line. It's more like a long sigh, a gradient of dimming where colour drains away until only blue survives, and then even that gives up. For a few hundred metres, the sea glows faintly like an endless dusk. Fish still swim there, plants still cling to life, and you can almost pretend the sun will find you again. But keep descending, and the blue turns grey, the grey turns black, and eventually there's nothing left to see at all. This is the place where light gives up, not because it wants to, but because physics allows no mercy here. Sunlight, as it turns out, is fragile. Water absorbs and scatters it ruthlessly. The red and orange wavelengths disappear first, devoured within the first 10 metres. Yellow fades after 50. Green lingers longer, which is why the shallows shimmer that familiar turquoise, but even it weakens as the distance grows. By 100 metres down, you're living in a world painted almost entirely in blue. Beyond 200, the light is a whisper, and beyond 1,000, it's gone. The photons simply can't survive the journey. They're scattered, absorbed, and converted into heat, their energy surrendered to the endless mass of water pressing down from above. It's a quiet kind of extinction, happening every second across millions of square miles. For the creatures that live in this fading zone, light is both a gift and a ghost. Some chase it, rising toward the surface at night to feed, then sinking back into darkness before dawn. Others avoid it, staying hidden from predators whose eyes still rely on brightness. There are fish whose pupils have grown enormous to capture the last scraps of illumination, and others that have lost their eyes entirely, deciding evolutionarily that sight was a waste of effort. Here, in the boundary between worlds, survival depends on how well you can sense what light cannot reveal. Pressure waves, chemical trails, faint electric signals, these become the language of existence. It's not blindness, its adaptation to a kind of seeing we can barely imagine. If you were to descend yourself, your eyes would fail before your courage did. At first, you'd notice colours slipping away. Reds turn black, oranges become brown, and your own skin takes on a bluish, almost alien tint. Then, as light dwindles, your pupils would widen, trying to gather what little remains. Eventually, there's nothing left to adjust to. Your body would still know up from down by the pull of gravity, but sight would no longer help you. The darkness isn't like night on land, where stars or city lights still offer some relief. It's absolute. A void so perfect it erases distance, shape and texture. Shine a flashlight and the beam stops a few meters away, swallowed by the water. Turn it off, and it's as though you've ceased to exist altogether. Scientists sometimes describe the ocean's light boundary as an inversion of the sky. On land, we look upward and see blue because air scatters sunlight. Underwater, we look upward and see blue because everything else has been taken away. The colour isn't abundance, it's residue. What remains when all the warmer tones have been stripped out. It's strange to think that what we call the colour of the sea is really the absence of most colours. But in a way, that's what makes it beautiful. Every shade of blue you see from the surface is light struggling, losing, and yet still reaching for you across impossible distance. This layer where light finally dies is sometimes called the dysphotic zone, the twilight of the ocean. It's a place of paradox, too dark for photosynthesis, too bright for total darkness. Plants can't live there, yet many animals rely on it as a highway between surface feeding grounds and the deep safety. At dusk, billions of organisms migrate upward in what may be the largest daily movement of life on Earth. Shrimp, fish, and plankton rise through the fading light to feed, then retreat before dawn to avoid predators. It's been called the vertical commute, and it happens every night without pause, a biological tide rising and falling with the rhythm of day and night. The distance they travel can be hundreds of meters. Scaled down to their size, it's the equivalent of a human climbing Mount Everest every single day. They do this not by choice, but by instinct, an unbroken pattern millions of years old. If you could somehow hover motionless in this dim corridor, you'd see flickers of movement unlike anything on land. Tiny points of light drift past, flashes of green or blue or violet. Bioluminescence, the ocean's own version of starlight. Down here, where the sun no longer shines, creatures make their own glow. Some use it to communicate, some to confuse predators, and some simply to lure prey close enough to strike. These lights are not reflections of the sun, but echoes of chemical energy. A different kind of brilliance that doesn't care whether it's day or night above. In a world where everything else has surrendered to darkness, life invents its own answers to the question of how to be seen. Human eyes are drawn to light instinctively. It's part of how we evolved, and part of why the deep ocean unsettles us. We're creatures of vision, built to navigate brightness and shadow. Take that away, and our sense of control unravels. Explorers who've descended into this region often describe a peculiar mix of awe and disquiet. The water feels thicker, not because it is, but because the absence of sight makes it seem so. You begin to imagine things moving beyond your reach, shapes that might be there or might not. Your brain fills the void with imagination, and imagination underwater can be a dangerous thing. The mind creates outlines where there are none, turns drifting particles into eyes, transforms shadows into movement. It's not fear exactly. It's more like the body remembering that it's out of its element. For machines, the challenge is different, but no less daunting. Cameras that function beautifully in shallow water become useless when light is gone. Artificial lighting helps, but only a little. The water scatters beams, creating a halo that reveals what's nearby but blinds sensors to anything beyond. It's like driving through dense fog with your high beams on. To see farther, researchers use sonar, which maps the surroundings through sound rather than sight. A pulse is sent out, and the returning echo reveals what lies ahead. It's clever, but it also means that our image of the deep is built not from light, but from vibration. Every map of the midnight zone, every contour we think we know, is a translation of echoes into shapes. We're not seeing the deep, we're hearing it through instruments, and calling that vision. Light's disappearance also changes how time feels down there. On the surface, our days are marked by the cycle of the sun. Morning, noon, sunset, night. Underwater, those cues vanish. Time dissolves into an endless present. A submersible pilot once said that in the deep, you stop measuring time by hours and start measuring it by battery life. The human body still keeps its rhythm. Hunger, fatigue, the need for warmth. But the environment offers no reminders. It's as though the concept of day itself has been left behind, floating somewhere far above you with the last scattered photons. In a way, this makes the deep ocean one of the few places on Earth where time truly loses meaning. Light and time are connected for us on land. Remove one, and the other begins to blur. There's something humbling about realizing how quickly light fails. It travels 93 million miles from the sun, crosses the vacuum of space, slips through the atmosphere, touches the surface of the ocean, and then within a few hundred meters, it's gone. All that effort, all that energy undone by water, yet without that loss, life would be impossible. The ocean's layers depend on it. The warmth at the top, the cold stability below, the circulation of nutrients between them, all of it exists because light can't penetrate deeply. The darkness isn't a flaw. It's a feature, a balance that keeps the planet alive. It's what allows surface creatures to thrive in warmth and deep ones to evolve in stillness. The ocean, in its own way, uses light surrender to create order. When we look at images from deep-sea exploration, it's tempting to imagine we're seeing the deep as it truly is. But every beam of light from a submersible is an intrusion, a temporary distortion of reality. The creatures caught in those beams often flee or freeze, their lives interrupted by something unnatural. In their normal state, they exist in darkness so complete that even their concept of visibility is different. Many deep-sea animals have skin that absorbs nearly all light, making them almost invisible. Some produce light, but in narrow wavelengths invisible to others. Some can see polarized light patterns beyond our comprehension. The world they inhabit isn't merely dark, it's organized around the absence of light as a normal condition. For them, illumination is the anomaly, not the norm. Humans, of course, can't help but illuminate. It's our instinct to bring light wherever we go, whether it's fire, electricity, or the glow of screens. In the ocean, that impulse meets resistance. The deeper we send our lights, the more we realize how little they reveal. The beam fades, the particles scatter it, and darkness always returns. In a sense, the sea reminds us of our limits. No matter how advanced our technology becomes, there will always be realms that remain beyond the reach of brightness. That's not failure. It's reality reminding us that exploration doesn't mean conquering. Sometimes it means accepting that some places prefer to remain unseen. Even in mythology, the deep sea has always been a symbol of the unknown, the place where light and certainty end. Ancient sailors spoke of monsters lurking where sunlight faded, not because they'd seen them, but because the human mind dislikes voids. The absence of light has always been the canvas for our imagination. We fill it with stories to make sense of what we can't observe. In that way, the Midnight Zone isn't just a part of the ocean, it's a reflection of how we handle the unseen. We measure it, map it, speculate about it, but in truth, we still fear it a little. Not the creatures, not the darkness itself, but the feeling of insignificance that comes with knowing how easily light, and by extension life, is erased by depth. As technology improves, our eyes reach farther, but the principle remains the same. The deeper we look, the more we rely on tools instead of senses. Cameras, sensors, sonar arrays, all trying to reconstruct what light once told us directly. Yet no amount of data can replace the simplicity of sunlight on water. That clarity, that directness, is gone the moment you sink too far. What's left is a mediated version of reality, filtered through instruments and translated into graphs and images. We call that knowledge, but it's still interpretation. Light's departure turns observation into inference, and exploration into a kind of listening. It's strange to think that an environment so utterly hostile could also be so peaceful. The water there is almost motionless. Currents move slowly, temperature changes barely at all, and noise is rare except for the occasional creak of geological movement or the distant song of a whale. The stillness isn't silence, it's the sound of equilibrium. In that balance, life continues quietly, indifferent to whether we understand it or not. The deep sea doesn't need light to validate its existence. It thrives in its own terms, shaped by chemistry, pressure, and time. The creatures there don't mourn the loss of light. They've never known it. If you think about it long enough, the idea of light giving up isn't just a description of physics, it's a reminder of scale. We live in a thin, fragile band of habitability, a few kilometers of air above us, a few hundred meters of light below. Everything we call the visible world fits into that narrow slice. Beyond it lies the majority of the planet, dark, cold, and indifferent. The midnight zone isn't far away in distance, but it's infinitely distant in experience. It's as much a psychological frontier as a physical one. To explore it is to confront how limited our senses truly are. For now, we stay mostly above it, sending our probes and cameras downward, watching from a safe distance as light fades. But every descent teaches us the same lesson. The ocean doesn't end when the light does. It simply changes, continuing in forms our eyes weren't built to see. And somewhere below that invisible horizon, life persists, quietly, patiently, without ever needing the sun. It's a world that doesn't wait for us to understand it. It just is. Pressure is an invisible thing until it isn't. You can't see it and you can't hear it, but the deeper you go, the more it becomes the entire story. Every extra meter underwater adds a little more weight, a little more force, until it becomes something monstrous, something that crushes without hesitation or drama. The surface seems peaceful, but it hides a kind of slow violence beneath it. Not the sharp kind that tears or breaks, but the relentless kind that squeezes and compacts until even metal begins to yield. Down there in the black stillness where light has given up, pressure isn't just a condition, it's the law. At sea level, the air above you presses with a gentle, familiar force, about 1 atmosphere, 14 pounds on every square inch of your body. You've lived with it all your life, so you don't notice. Your body is balanced against it. The fluids inside you push back with equal strength, and the two forces cancel out perfectly. But water is heavier than air, about 800 times denser, and it doesn't forgive imbalance. Every 10 meters you descend adds another atmosphere of pressure. By 100 meters, it's 10 times what you're feeling right now. By 1,000, it's 100 times. By the time you reach the deeper parts of the midnight zone, the pressure is over 1,000 times greater than at the surface. That's roughly 8 tons on every square inch. It's a number so large that it stops feeling meaningful. It's not the kind of weight you can imagine holding. It's the kind that holds you instead. If a human body could somehow exist at those depths without protection, it wouldn't last long. The lungs would collapse first. They'd shrink under the weight until the ribs themselves began to fold inward. The air spaces in the ears and sinuses would implode, and blood would lose its ability to carry oxygen efficiently. Even the calcium in bones would begin to deform if given time. But long before that happened, unconsciousness would arrive. It's not a violent end, just a quiet one. The body overwhelmed by a force it can't resist. The idea that life could not only survive but flourish in such conditions feels impossible. Yet the ocean is full of creatures that do exactly that, every moment of every day. The reason life exists at all in that environment comes down to adaptation, but not the kind we usually talk about. Deep-sea life doesn't just adapt to pressure, it's built by it. From the molecular level up, everything about those organisms assumes that compression, density and stability are constants. Their membranes are flexible where ours are rigid, their proteins structured in ways that prevent folding errors under stress, their internal fluids matched perfectly to the outside environment. The creatures of the deep aren't fighting pressure. They are pressure in the sense that their existence has been sculpted entirely by it. Bring them to the surface and they die, not because they're fragile, but because our world is too weak for them. They're crushed by absence rather than weight, undone by the lack of the force that defines their normality. For us, though, pressure has always been the barrier. It's the wall we can't climb through. Early diving suits were designed for shallow depths, barely enough to explore the sea floor near harbours or reefs. Made of brass, leather and heavy canvas, they looked more like miniature submarines than clothing. The suits worked by pumping air from the surface through long hoses, but as divers went deeper, the air compressed faster than pumps could compensate, and one mistake meant the suit collapsing inward like a tin can. Many divers never came back up. Even as technology improved, that invisible weight kept setting limits. Steel and titanium replaced brass, electricity replaced manual pumps, but physics never changed. There's no negotiating with density. To reach beyond the point where a human body can function, you need a machine that doesn't mind being crushed. Submarines built for deep dives look nothing like the sleek vessels from movies. They're more like thick-walled spheres, sometimes barely big enough for 2 or 3 people. The shape isn't aesthetic, it's survival. A sphere distributes pressure evenly in every direction, minimizing weak points. Flat walls would buckle, sharp edges would fracture. Every bolt, every seam, every weld must be flawless. Engineers spend years perfecting designs that can endure just a few hours of exposure to those depths. Even so, each dive carries risk. Metal fatigues. Microscopic imperfections expand. Pressure finds them all eventually. The people who descend inside those machines speak about the sound of it. The creaking, the occasional crack or groan that echoes through the hull. They describe it as alive, as though the submarine itself is aware of what it's enduring. Every pop is a reminder that the ocean is pressing. Always pressing. Waiting for any lapse in human precision. Pilots know the numbers, they know how thick the walls are, how the pressure gauges behave, but the psychological weight is something else. There's no room for panic, no space to move much at all. You sit still, you breathe slowly, you watch the monitors, and you trust the engineering. The difference between a safe descent and an implosion is often less than a fraction of a millimetre. There's a particular silence that comes with that depth. Not the peaceful quiet of a forest or a sleeping house, but something heavier, denser. Sound travels farther underwater, but it becomes muted, slower, stretched by distance. Inside a submersible, you hear your own heartbeat more clearly than the world outside. Communication with the surface becomes lagged or distorted. Light doesn't reach you, and radio waves die almost instantly. The only signals that pass reliably are acoustic, sonar pings and short bursts of encoded sound. In that isolation, you start to realize how alien the deep ocean really is. It's not just another environment, it's an entire physics, one that shrinks everything familiar into fragility. Pressure changes not only the body and the machine, but also the behavior of matter itself. Gases dissolve more readily into liquids, metals become less elastic, and even chemical reactions shift their pace. Water at those depths is not the same as the water in your glass. It's colder, denser, and near the sea floor, often superheated by vents that leak minerals from the Earth's crust. The result is a strange mix of boiling and freezing that exists in equilibrium only because of pressure. At the surface, it would explode into steam instantly, but down there, it remains liquid. The deep sea vents around these areas are some of the most extreme environments on the planet, and yet they teem with life. Tube worms, shrimp and bacteria that thrive not on sunlight but on chemistry itself. Pressure doesn't kill them, it defines them. This constant force also shapes geology. The seafloor isn't a flat desert, though it's often depicted that way. It's folded and cracked by tectonic movement, dotted with mountains taller than Everest and trenches deeper than any valley on land. The Mariana Trench, the deepest known point in the ocean, drops almost 11 kilometers down. At that depth, the pressure is more than 1,000 times what we feel at sea level. Only a handful of vehicles have ever reached it, and fewer still have done so with humans aboard. Even those that did spent barely minutes there before beginning the long ascent back. The bottom of the trench isn't empty. It's filled with fine sediment, rocks, and life adapted to stillness. But it's a world that will never be ordinary to us. We can visit it, but not live there. We can observe it, but not belong. To grasp what that pressure means in practical terms, consider this. At 10,000 meters deep, every square inch of a submersible's hull bears the weight of about 7 tons. Multiply that across the surface area of even a small vessel, and the total load exceeds 100 million kilograms. That's equivalent to balancing a skyscraper on something the size of a small car. The only reason these machines don't collapse instantly is because their internal structure perfectly counterbalances the force outside. There's no margin for error. Even a single screw failing could be enough to let the ocean in, and when it comes in, it does so at supersonic speed, turning the interior into vapour in milliseconds. That's the reality engineers must design against every single time. Yet for all this danger, pressure isn't the villain. It's just the environment. It doesn't choose to destroy, it simply exists. Humans frame it as an obstacle because it defines our limit. But if we were creatures of the deep, we'd think of it as comfort, as home. The fish and crustaceans that live at those depths don't have lungs or air pockets. They're made of water and soft tissue, equal in density to their surroundings. The pressure doesn't crush them because there's nothing inside resisting it. Their bodies are a perfect truce between inner and outer forces. It's a kind of harmony we can only marvel at, because everything about us is built for air. Every so often, deep-sea creatures are pulled to the surface by fishing nets or research trawls, and what happens next is tragic but telling. Their bodies expand, their organs rupture, their eyes bulge outward. It's not violent by intent, it's just physics in reverse. They're brought to an environment too light for them to hold shape. The same laws that make them strong in the deep make them fragile above. Pressure doesn't just define where they live, it defines what they can be. That's true for us too, though on a different scale. We're built for a narrow range of pressures, temperatures and gases. Change those and we cease to function. The ocean reminds us of that, quietly and without cruelty. For engineers, the challenge of exploring this world isn't just surviving it, but understanding how to measure it accurately. Traditional sensors often fail because their casings deform under stress. Electronics stop working, seals leak and cables fracture. Designing instruments that can withstand those forces while still gathering data is like asking a camera to work inside a volcano without melting. Every success is temporary. After a few dives, components weaken. The constant compression and release of pressure fatigues materials, much like bending a paperclip back and forth until it snaps. Even titanium, one of the strongest metals known, eventually develops microscopic cracks if cycled enough times. The deeper we go, the shorter the lifespan of everything we bring with us. The history of deep exploration is filled with examples of machines that worked beautifully on paper, but failed the moment they met real pressure. In the 1960s, the bathyscaphe Trieste, a steel sphere suspended beneath a gasoline-filled float, became the first vessel to carry humans to the deepest point of the ocean. When it reached the bottom, one of its outer windows cracked under the pressure. The crew heard it snap like a gunshot. They stayed for barely 20 minutes before beginning their ascent, not because they wanted to leave, but because they had to. Even then, the submersible creaked and groaned the entire way back up. It was a triumph of engineering and a reminder that the ocean always wins eventually. Since then, newer submersibles have gone deeper, stayed longer, and gathered more data, but the fundamental challenge remains. The deeper you go, the more energy you need just to resist the ocean. That means thicker hulls, heavier materials, and stronger power systems, all of which make the craft harder to maneuver. It's a constant trade-off between strength and mobility. Autonomous robots can go deeper because they don't need to carry humans, but even they must balance endurance against fragility. The deeper we send them, the more they risk becoming permanent residents of the abyss. Pressure doesn't just test machines, it tests patience. Every descent takes hours, and every failure costs years of work. Research teams spend entire careers designing probes that might only operate for a single dive. If something breaks, retrieval is often impossible. The ocean doesn't return what it takes, it keeps the evidence. That's part of why exploration remains so limited. Every dive is expensive, dangerous, and fleeting. We learn a little each time, but we lose just as much. The Midnight Zone isn't a place that welcomes visitors. It tolerates them briefly and then closes over them like nothing happened. Still, it's easy to see why people keep trying. There's something irresistible about testing the edge of what's possible. Every time we push deeper, we redefine our understanding of the planet. We discover new species, new geological formations, even new chemical processes that could change how we think about life itself. The pressure may be immense, but so is curiosity. One is physical, the other psychological. Between them, exploration happens in bursts, moments of clarity separated by long stretches of silence and waiting. Pressure in the ocean isn't a metaphor for human struggle, but it might as well be. It's constant, invisible, and absolute. It doesn't care who you are or how advanced your technology has become, it simply exists, shaping everything that dares to enter its realm. In that way, it's a reminder of humility. For all our strength, intelligence, and ambition, we're still fragile creatures bound by the physics of our own planet. We live in a thin band of comfort between the crushing depth below and the freezing vacuum above. Everything else, the Midnight Zone, the mountains of the moon, the outer edges of space, belongs to different pressures. For those who study the deep, this isn't discouragement, it's inspiration. The fact that the ocean can still resist us after centuries of effort means there's something left to learn. Every creak of a hull, every groan of metal, every tiny camera that survives longer than expected, these are the sounds of discovery. We may never conquer the deep, but we can still listen to it, measure it, and understand it a little better each time. And as long as curiosity remains heavier than fear, there will always be someone willing to descend again. The deeper we go, the more it feels like descending not just through water, but through scale itself, through a version of nature that dwarfs everything human. Pressure becomes not just a physical force, but a kind of silence. A silence so dense it has weight. And somewhere below that silence, deeper still, life continues, indifferent to whether we ever reach it or not. When you look at the ocean from the shore, it seems impossible that something so vast could be hidden. It stretches to the horizon, gleaming in sunlight or rolling under clouds, and from almost any angle, it appears to be the most visible thing on Earth. It's hard to imagine calling it unseen, but that's exactly what it is. The ocean hides itself in plain sight, not by secrecy, but by scale. You can stand before it, fly over it, photograph it, and still know almost nothing about what's underneath. The surface is just a shimmer, a thin and restless boundary that conceals everything that makes the ocean what it is. For most of human history, that surface was all anyone knew. People fished its edges, crossed it in fragile ships, worshipped it, feared it, but they didn't explore it. The depths remained theoretical, a rumour told by sailors who had seen strange creatures rise from the dark. The ocean was infinite to them, unknowable and perhaps even endless. The ancient Greeks imagined that the sea flowed off the edge of the world. Early maps marked blank blue spaces with warnings rather than information. "Here be monsters," they wrote. Not as fantasy, but as honesty. The truth was they didn't know. Even now, centuries later, with satellites orbiting overhead and sensors probing the deep, we still don't know as much as we pretend to. The ocean remains, in most ways that matter, a mystery. You've probably heard the phrase that we know more about the surface of Mars than we do about the bottom of our own ocean. It's repeated so often it's almost cliché, but it's true. We have high-resolution maps of another planet, yet when it comes to Earth, most of the seafloor remains a blur of low-resolution estimates. The reason is simple physics. Light, sound, and radio behave differently in water. Satellites can scan the land and even the moon because electromagnetic waves travel freely through air and vacuum. Water blocks them. Even the most advanced sensors can't penetrate more than a few meters below the surface. That means that every detailed image you've seen of the ocean floor isn't from space at all. It's built from indirect data gathered by ships using sonar, and even that covers only a fraction of the total. The ocean covers about 71% of the planet's surface. Of that, less than a quarter has been mapped in detail. The rest is estimated through mathematical models, informed guesses based on gravity measurements and the behaviour of waves at the surface. It's like trying to understand a cathedral by tracing the shadow it casts on the ground. You can tell it's there, you can measure its outline, but the architecture, the carvings, the hidden chambers, those remain invisible. That's what we mean when we say the ocean hides in plain sight. It's not just deep, it's opaque, both literally and figuratively. Even when we send machines down, our vision remains narrow. A submersible's lights illuminate only a few meters. A camera records what fits inside its frame. The rest, the overwhelming majority, lies outside of view. Each dive is a pinprick of knowledge in an ocean of darkness. You could send thousands of them and still not come close to seeing it all. That scale is difficult to grasp. If you were to spread the deep ocean across a map and mark every point we've actually visited with a human-operated vehicle, the dots would barely show. They'd be smaller than dust. The ocean hides its topography as effectively as any secret in nature. Beneath the waves lie mountains taller than the Himalayas, valleys deeper than the Grand Canyon, plateaus the size of continents. There are volcanoes erupting constantly, undersea rivers carved by dense saline water, cliffs so steep they collapse under their own weight. Yet you could sail over all of it and see nothing. The surface betrays almost no hint of the chaos beneath. Even the colour of the water tells you little. Calm blue seas can conceal violent geological activity. Stormy grey waters can sit above tranquil plains. The surface is a mask, always moving, always changing, but never revealing. Part of what makes the ocean's invisibility so persistent is its hostility to our methods of discovery. Water scatters light, absorbs heat, and muffles sound. Electronics corrode, seals fail, lenses fog. Everything we build to explore it must fight against a medium designed to undo it. The result is that most of our understanding comes from fragments, pressure readings, temperature profiles, sonar scans, that scientists assemble into mosaics of inference. It's a slow process. A research ship might spend months surveying a region smaller than a city, mapping it meter by meter, line by line. Meanwhile, the rest of the ocean waits, unrecorded, unobserved, existing perfectly well without our attention. That hiddenness has consequences. Because we don't see the ocean's interior, we often misunderstand how it works. We talk about it as though it's uniform, but it isn't. It's layered, dynamic, full of contrasts and currents that shape everything from weather to climate. Warm water moves along the surface, cold water flows beneath, and the boundary between them, called the thermocline, shifts constantly. These movements regulate temperature across the planet, drive storms, and even influence patterns of rainfall and drought. Yet most of it happens unseen, deep below, where light or satellites can reach. The real machinery of Earth's climate operates out of sight in the ocean's hidden body. When you stand at the shore and watch waves break, what you're really seeing is the skin of that machinery. It's easy to think the waves are the ocean itself, but they're just surface patterns, energy passing through water, not water travelling through space. The real motion happens beneath, in slow, massive circulations that take centuries to complete. A parcel of water sinking in the North Atlantic might not resurface for 1,000 years. It drifts through the abyss, carrying heat, carbon and minerals, before rising again somewhere near Antarctica. That loop connects every sea and ocean into one global system. It's invisible from above, but it's the reason our planet's climate has remained stable enough for life. Without that hidden circulation, the Earth would swing between extremes of heat and cold. The ocean's secrecy is what keeps us alive. It's ironic that we've built satellites capable of photographing distant galaxies, yet when it comes to the world beneath our own feet, we're still explorers in the dark. Even the tools that work best underwater, sonar and submersibles, are limited by cost and scale. Mapping the entire ocean with the same precision as land would take decades of continuous effort and thousands of specialized ships. The data would fill endless servers and still be incomplete, because the ocean changes constantly. Currents shift sediments, volcanoes reshape the seafloor, earthquakes create new ridges. To truly map it, you would have to start again the moment you finished. There's also something psychological about our blindness. We live on land, and our instincts are tuned to air, not water. The ocean resists not just our tools but our imagination. It's hard for us to picture a world without sky, without horizon, where movement is slow and direction uncertain. Even when we think about the sea, we tend to visualize the parts that resemble our own environment. Reefs, fish, sunlight, colour. The rest, the midnight zone and the abyss below it, doesn't fit neatly into our mental world. It's too foreign. We describe it with words borrowed from space, calling it alien or otherworldly, as though it belongs somewhere else. But it's not alien at all. It's Earth in its purest form. If you look at a globe, most of what you're seeing is water. The continents are the exception, the exposed ridges of a much larger structure. The real planet, the majority of it, is oceanic. Our cities, our fields, our entire civilization occupy the minority surface of a water world. Yet we talk about the ocean as though it's an addition, an extra feature. It would be more accurate to say that land is the exception and the ocean is the rule. That reversal of perspective is unsettling. It reminds us that we're not the centre of this planet's story, just one of its temporary details. The ocean's ability to hide also extends to life. Most marine species remain undiscovered. Every deep-sea expedition reveals something new. A fish with transparent skin, a jellyfish that glows like molten glass, a worm that lives on methane near hydrothermal vents. Scientists estimate that as much as 80% of ocean life has never been seen by humans. That's not a poetic guess. It's based on numbers. The vastness of habitat versus the number of recorded observations. Every time a submersible descends into a region never explored before, it almost always finds at least one species new to science. Sometimes entire ecosystems appear where none were expected, living off chemical energy instead of sunlight, thriving in conditions once thought sterile. This constant discovery has changed how we think about life itself. For centuries we assumed that the absence of light meant the absence of biology. The discovery of deep-sea vents in the 1970s shattered that assumption. There, at depths where sunlight had never reached, life was abundant, powered not by photosynthesis, but by chemosynthesis. Organisms using chemicals like hydrogen sulfide to produce energy. That revelation forced scientists to reconsider what habitable means. If life can exist in the crushing dark of our own ocean, then perhaps it can exist elsewhere too, on icy moons or planets with subsurface seas. The search for alien life now begins by studying the most hidden parts of our own world. But even these breakthroughs highlight how little we've seen. Most of the ocean's ecosystems remain unvisited, and many may vanish before we even know they exist. Human activity reaches the deep indirectly through pollution, warming, and noise. Microplastics drift into trenches once thought untouched. Carbon emissions change the chemistry of seawater, making it more acidic and less stable for the creatures that live there. Even sound from ships, drilling, or sonar travels for thousands of kilometers underwater, disrupting communication among whales and other species that rely on low-frequency calls. The ocean hides, but not perfectly. Our impact finds its way in. It's sobering to realise that we've mapped Mars with lasers and cameras, yet our understanding of the ocean often comes from educated guesswork. We imagine the seafloor as static, but it's alive with motion. Spreading ridges where new crust forms, subduction zones where old crust sinks, vents releasing minerals that could one day be mined. Industry has already begun eyeing those depths for resources. Rare earth metals, manganese nodules, cobalt. Extraction would require machines capable of surviving pressures and conditions few have ever endured. The ethical questions of such ventures are immense. How do you regulate activity in a place no one can see? How do you protect ecosystems we haven't even discovered? The temptation of hidden wealth runs deep, but so does the risk of irreparable harm. The ocean's invisibility has always made it a kind of mirror for our imagination. We project onto it what we can't face elsewhere: mystery, danger, beauty, fear. When we say it's unexplored, we're also admitting that it reflects our ignorance back at us. The more we learn about it, the more we realise how much we don't know. It's not just the midnight zone or the trenches that remain uncharted, it's the entire interconnected system, from surface waves to abyssal plains. The sea isn't a blank space waiting to be filled with knowledge. It's a living complexity that resists simplification. For scientists who study it, this resistance isn't discouraging. It's what makes their work meaningful. Every measurement taken, every sonar line traced, every new creature recorded adds one more thread to a tapestry that will never be finished. There's a strange comfort in that. The idea that some parts of the world will always remain beyond complete understanding. The ocean doesn't hide because it's malicious. It hides because it can. It's big enough to keep secrets, dense enough to protect them, and old enough to have forgotten how to reveal them. If you stand again at the edge of the sea, listening to the waves and watching the horizon blur into sky, it's easy to feel like you're looking at something you know. But remember that below that calm surface lies an entire planet's worth of geography, chemistry, and life, most of it unseen and unimaginable. The ocean hides not by darkness alone, but by immensity. We think of it as background, as scenery, but it's the main story. It's the reason the air is breathable, the climate stable, the continents alive, and it will continue, whether we explore it or not, moving silently under the cover of light, a whole world hidden in plain sight. And if the weight of that thought feels too large, just remember that everything we are, the water in our blood, the salt in our cells, once came from there. The ocean isn't separate from us. We carry its memory in our chemistry, even if we've never seen its true depths. The mystery we keep chasing below the waves isn't just about discovering the planet. It's about remembering the part of it that still moves quietly inside us, unseen but always present, hiding in plain sight just like the sea itself. Every time we send something into the deep, it trembles. Not out of fear, of course, but because everything we build for that world has to exist on the edge of its own endurance. Machines are strong on the surface, confident in air and gravity, but underwater, especially in the depths where light can't reach, they lose that certainty. They creak, groan, and hum under pressure, like living things holding their breath. It's not because they're fragile, they're the best we can build, but because the ocean is better at breaking things than we are at defending them. Every bolt, every sensor, every seal carries the quiet knowledge that it might be the one to fail. The machines we send down are not explorers in the romantic sense. They're tools, patient, methodical, and indifferent to glory. They go where humans cannot, stay longer than we could, and return with fragments of truth. They don't feel awe or fear, but those feelings are built into the people who design them. The engineers know what they're asking of their creations: to survive crushing pressure, freezing temperatures, and total darkness. They design with precision measured in microns, test every part to exhaustion, and still, when the descent begins, they hold their breath. Because no simulation, no laboratory test can perfectly reproduce what happens thousands of meters below the surface. Every descent is a conversation between human intention and nature's indifference. On the surface, the launch feels routine. Cables tighten, cranes swing, and the machine slides into the water with a splash that looks almost casual. But as soon as it sinks past the light, the routine ends. Communication slows, signals distort, and within minutes, the machine enters a world where nothing human exists. From that moment on, the ocean decides what happens. It presses against the hull, muffles every sound, and tests the integrity of every weld. A few thousand meters down, even steel begins to sigh. The first generations of deep-sea machines were simple by today's standards, but they were acts of bravery disguised as engineering. In the 1950s, when scientists wanted to see what lived below 4,000 meters, they had no computers, no digital controls, just cables, lights, and hope. The bathyscaphe Trieste, which would later reach the deepest known point on Earth, was an example of pure audacity. Its design was crude but brilliant. A heavy steel sphere for the crew, suspended beneath a massive float filled with gasoline for buoyancy. Gasoline was chosen not for its energy, but because it's lighter than water and resists compression. The whole contraption looked improvised, like a piece of industrial machinery that had decided to dream, but it worked. In 1960, it carried 2 men to the bottom of the Mariana Trench, nearly 11 kilometers down. When they reached the sea floor, one of the small plexiglass windows cracked under the pressure with a sound like a gunshot. They stayed just long enough to confirm that life existed even there. Then began the slow ascent back to the surface. That moment remains one of the great milestones of exploration, yet more than 60 years later, we've barely repeated it. The reason is simple. The ocean doesn't forgive mistakes, and every trip costs an immense amount of time and resources. Each machine that ventures into the deep is a miniature spacecraft built for a different kind of space. One filled not with vacuum, but with weight. And weight is harder to fight. As technology advanced, we built new kinds of machines, remote-operated vehicles or ROVs, connected to ships by long umbilical cables. They allowed scientists to explore without the risk of sending humans inside, controlling cameras and manipulators from far above. These ROVs became the workhorses of deep-sea research, capable of collecting samples, recording high-definition video, and measuring temperature and chemistry in real time. But even they aren't immune to the ocean's hostility. The cables that tether them can stretch for miles, twisting and tangling in unseen currents. A sudden shift in water movement can snap a line as if it were thread. Salt water corrodes connectors, pressure warps housings, and small leaks turn deadly in seconds. Each dive is an act of patience. The descent can take hours. The operators watch screens filled with grainy images, adjusting thrusters by millimeters. The vehicle moves slowly because speed is risk. Every propeller must balance thrust with stability. Even a minor collision with the seafloor could cripple the entire mission. When the machine lands successfully, the crew cheers quietly, not because they've conquered the deep, but because nothing broke yet. What follows is a dance of careful observation. Cameras pan across mud plains and rock formations that no one has ever seen before. Mechanical arms collect samples as delicately as human hands. The machine's lights create small islands of visibility in a black ocean that swallows them whole again the moment they move on. But no matter how sophisticated these machines become, they still tremble. Sometimes it's physical vibration from the motors. Sometimes it's the signal delay that makes the operator's commands feel like echoes. And sometimes it's the deep itself, pressing its presence into every joint and seal. Those tremors remind everyone involved that exploration isn't just about discovery, it's about endurance. Machines are extensions of us, and when they tremble, it's because they're meeting something bigger than anything we can fully control. The latest generation of deep-sea explorers doesn't even have pilots. They're autonomous vehicles, programmed to navigate and map without real-time human input. They glide through darkness guided by sensors and algorithms, tracing the contours of the seafloor with sonar beams and laser scans. They're quieter, more efficient, and capable of travelling farther than tethered machines. Yet even these advanced explorers face the same elemental challenge: pressure and isolation. They may not fear it, but their creators do. When an autonomous vehicle disappears into the depths, there's always a chance it won't come back. Sometimes the pressure cracks its casing, sometimes the current carries it away, and sometimes it simply stops responding, vanishing into silence. The ocean takes it, and that's the end of the story. For every successful mission, there are failures that never make headlines. A sensor floods, a connector fails, a battery ruptures under strain. Entire machines have been lost to the deep, each carrying data, cameras, and years of work. The ocean floor is littered with their remains, fragments of technology resting beside the skeletons of whales and the ruins of ships. They become part of the landscape, absorbed into the same slow rhythm of decay and sedimentation as everything else. It's easy to forget that our machines leave traces too, that even exploration has a footprint. And yet, despite the losses, we keep building them. Each generation learns from the failures of the last. Engineers develop alloys that resist corrosion, cameras that see in near-total darkness, and software that can interpret sonar returns into maps of astonishing detail. In some ways, our technology has evolved faster than our understanding. We can now send a drone to the bottom of the ocean and have it record entire landscapes in 3 dimensions. But interpreting that data, understanding what it means in geological or biological terms, can take years. The machines bring back more than we can immediately comprehend, like messengers returning from a world that speaks another language. One of the most striking things about deep-sea technology is how often it borrows ideas from nature. Engineers study fish that withstand pressure by using flexible skeletons and compressible tissues. They look at jellyfish that drift efficiently through currents without rigid structure, and at bacteria that stabilize their membranes with unique molecules. These biological tricks become blueprints for design: flexible housings, adaptive materials, even soft robotics, all inspired by creatures that have already solved the problems we're still struggling with. It's a quiet form of collaboration between biology and technology, separated by millions of years but connected by necessity. Sometimes, when the machines send back footage, the images feel almost unreal. The lights illuminate creatures that look like hallucinations: translucent eels with ribbon fins, squid with eyes like moons, fish whose teeth curve backward into their skulls. These sights aren't staged or exaggerated. They're simply what exists when evolution has enough time and pressure to experiment. Watching them on a screen aboard a ship, scientists often fall silent. The wonder never fades, even after decades of work. For a moment, the machine becomes more than a tool. It becomes a witness. But there's also a kind of loneliness to those images. The camera sees, but it doesn't feel. It captures the movement, but not the temperature of the water, the silence of the dark, or the weight of the surrounding miles. Machines record perfectly but understand nothing. That's our role, to look at the data and translate it into meaning. In that sense, every deep-sea robot is half-blind without us, and we are half-blind without it. The partnership works because both sides supply what the other lacks. Sometimes the ocean tests that partnership harshly. There are moments when the machine is ascending after a long dive, carrying priceless samples or irreplaceable footage, and something goes wrong. A thruster fails, a cable snags, or a buoyancy system refuses to release. In those moments, time slows for the crew. They watch the readouts in silence, calculating, waiting. Hours pass. Then, maybe, a faint signal reappears. The machine is rising. The relief is quiet, not triumphant. It's a recognition that once again, against all odds, the deep has allowed a return. The trembling of these machines is not weakness. It's the sound of tension between two realities, one mechanical, one elemental. Every creak and vibration is proof that we've managed, however briefly, to bridge that divide. It's strange to think that some of the most advanced technology on Earth spends its existence wandering through darkness, performing tasks in isolation that no one will ever witness directly. They are explorers without audience, their achievements measured not in spectacle but in persistence. Even now, new types of machines are being imagined, swarms of small drones that can map vast areas cooperatively, robots powered by chemical gradients instead of batteries, vehicles that use artificial intelligence to learn from each dive and improve their efficiency autonomously. Each design brings us closer to understanding the ocean, yet none will ever fully conquer it. The sea is too vast, too dynamic, too alive to be reduced to pure data. Our machines may move through it, but they will never own it. There's an old saying among oceanographers, the deep sea doesn't care about your schedule. It's said half-jokingly, but it captures the truth. Weather delays launches, equipment malfunctions, funding dries up, and still the ocean waits unchanged. It doesn't reveal its secrets on demand. The machines tremble because they are temporary. They enter a timeless world, perform their brief mission, and then return. Or don't. That impermanence gives their work a strange dignity. Each dive is both a test and an offering. When the footage finally reaches the surface and the data is processed, what emerges isn't just information. It's a glimpse into a place where human concepts of fragility and endurance lose meaning. The ocean has existed for billions of years without eyes or cameras to witness it, and it will continue long after our machines stop working. Yet the act of looking, of trying to see, connects us to it in a profound way. Every flicker of light from a submersible, every sonar ping echoing through miles of water, is a declaration of curiosity, our small attempt to say that we were here, that we wanted to understand. If you listen closely to the recordings from deep dives, you can sometimes hear the faint noises of the machines themselves, the hum of motors, the distant creak of metal expanding under stress, the occasional ping from sonar. It's mechanical, yet oddly soothing, like the breathing of something immense and alive. Those sounds remind us that exploration isn't a clean or effortless process. It's messy, uncertain, and filled with moments of waiting in the dark. But in that darkness, our machines keep moving, trembling but determined, carrying our questions farther than we can go ourselves. And somewhere down there, amid the silence and the pressure, they continue their slow, careful work. Tiny islands of human invention drifting through a black ocean that neither notices nor needs them, yet somehow seems to welcome them all the same. In the dark, everything that glows becomes a story. Light in the deep isn't just brightness, it's language, defense, deception, and survival. Where the sun cannot reach, life has found its own way to bring colour into existence. It's strange to think that in the blackest parts of the ocean, where light has been extinct for millions of years, creatures have learned to make their own. It's not magic or mystery, it's chemistry and adaptation, working together in silence. The deep is a theatre of light built without a sky. When you picture darkness, you probably imagine something empty. But the deep ocean is the opposite. The darkness there is an absence, it's background. Against it, every flicker of blue or green becomes extraordinary. The faint pulse of a jellyfish, the slow rhythm of a fish's lure, the spiral of plankton as it drifts. All of these are performances meant to be seen, if only by the right eyes. In a place without sunlight, light has to be made deliberately, molecule by molecule, reaction by reaction. Bioluminescence, the ability of living things to produce light, is common in the deep. Some scientists estimate that as many as 9 out of 10 deep-sea species can glow in some way. The chemistry varies, but the principle remains the same. Within specialized cells called photophores, a compound called luciferin reacts with oxygen in the presence of an enzyme called luciferase. The result is light, usually blue or green, because those colours travel farthest through water. Unlike fire, this glow produces no heat, no flame, no smoke. It's pure energy, released in a controlled shimmer that can last for seconds or hours, depending on the creature's purpose. And everything in the deep has a purpose for light. For some, it's camouflage. It sounds paradoxical, but glowing can make you invisible. Many animals use a trick called counter-illumination, producing light on their undersides that matches the faint brightness of water above. Seen from below, they disappear, blending into the dim background instead of casting a shadow. Others use light as a decoy, releasing flashes or clouds of glowing fluid to distract predators while they escape. Some even have detachable glowing parts, small sacs of bioluminescent tissue that drift away like flares, pulling danger in the wrong direction. There are hunters, too, that use light to deceive. The most famous is the anglerfish, with its lure, a filament tipped with a glowing organ filled with bacteria that generate light. It dangles the lure like bait in front of its mouth, waiting patiently as curious prey approaches. When the moment is right, the darkness closes like a door. The anglerfish's light isn't its own though, it's borrowed. The glow comes from symbiotic bacteria that live inside its body, feeding on nutrients in exchange for providing illumination. It's an ancient partnership, proof that even in a world of isolation, cooperation still evolves. Other predators use more elaborate tactics. Some squid emit bursts of light from their tentacles to confuse prey, creating strobe-like flashes that disorient and dazzle. Certain species of dragonfish have evolved the rare ability to produce red light, invisible to most deep-sea creatures but visible to themselves, allowing them to hunt under a private wavelength, unseen by others. Some jellyfish use light defensively, glowing in sudden, brilliant pulses that startle attackers. And then there are creatures that use bioluminescence to communicate, sending coded signals to attract mates or warn rivals. To us these patterns might look random, but to them they're sentences written in light. It's easy to forget that these displays are happening constantly, all over the deep ocean, even right now as you listen. Every moment, billions of organisms are blinking, pulsing and shimmering in the dark. If you could hover there without light of your own, you'd see faint sparkles drifting past like stars. The ocean's depths, often described as black voids, are in fact full of motion and glow, a kind of slow cosmic snowfall of living fire. It's not bright, but it's everywhere, subtle enough that you could miss it if you blinked, eternal enough that it never really stops. The way these lights behave tells scientists a lot about the ecology of the deep. For example, the distribution of bioluminescent species follows patterns of predation and resource availability. Where food is scarce, lights are used sparingly, a flicker here, a lure there, because energy is precious. In richer regions, like near hydrothermal vents or along continental slopes, displays are more elaborate. Some organisms synchronize their flashes, forming waves of light that move through the water like breathing. Others react to disturbances, glowing brighter when touched, as though the ocean itself were made of living embers that awaken at a gesture. Human eyes weren't built for this. We can't fully perceive the subtleties of deep-sea bioluminescence. Cameras can capture the glow, but not the texture, not the way it feels to see colour suspended in a world that shouldn't have any. The footage we see on screens, the glowing fish, the The blue spirals, the drifting jellies, is filtered, adjusted, framed for brightness. The real experience is quieter. The light doesn't cut through the dark, it melts into it. Each glow fades slowly, like breath in cold air, blending with the shadows instead of banishing them. It's tempting to romanticize all this, to turn it into metaphor, but for the creatures themselves, light is practical. It's how they find food, avoid death, reproduce, and communicate. Their bodies are laboratories of chemical precision, honed over millions of years to use photons the way we use words. Some creatures can control the intensity and duration of their glow, dimming it to whisper or brightening it to shout. Some can even aim it, focusing the emission through reflective tissues like natural mirrors. Evolution, patient and blind, has built a language that speaks in radiance. And then there are the ones we still don't understand. Occasionally submersibles capture patterns of light that don't match any known species. A faint grid of blinking points, or a moving spiral that seems organized rather than random. Sometimes it's mechanical, reflections from the vehicle's lights, but sometimes it isn't. There are stories from research teams who've seen what looked like massive, slow pulses spreading across the seafloor, too rhythmic to be coincidence. No one knows what they are. Maybe schools of luminous plankton drifting together. Maybe something larger, something we haven't yet classified. The deep doesn't reveal all its performers at once. Not all bioluminescence is constant. Some creatures use it only during certain life stages, or only in response to specific conditions. The patterns change with depth and temperature, with season and geography. In some regions, especially near continental shelves, the glow is strong enough to be visible from space. Satellite images have captured entire stretches of ocean, faintly glowing at night, caused by vast blooms of bacteria that light up the water's surface. Sailors used to call these milky seas. They'd report sailing through water that shimmered like glass, glowing without moonlight, so bright they could read by it. For centuries, those reports were dismissed as fantasy. Now we know they were real. Another reminder of how the ocean's mysteries often live right before our eyes, unnoticed or unbelieved. The existence of bioluminescence also changes how we think about light as a concept. On land, we associate light with energy, warmth, and safety. In the deep, it's the opposite. Light is risk. It can attract attention from predators, reveal location, or consume precious oxygen. The creatures that use it do so carefully, balancing the need to be seen with the danger of exposure. Each flash is a decision, a signal that might save or doom them. It's an economy of visibility, where survival depends on how wisely light is spent. Scientists studying these adaptations have discovered potential applications far beyond marine biology. The same chemicals that allow deep-sea creatures to glow have been used in medical imaging, genetic research, and even cancer detection. Luciferase enzymes serve as natural markers for cellular activity, letting researchers see how biological processes unfold in real time. The deep-sea survival strategies, honed in silence and pressure, are shaping tools that help us understand our own bodies. It's another quiet link between worlds that seem separate but aren't. When you watch a video of bioluminescent creatures, it's easy to forget how large and empty the space around them is. Each glowing point floats in water that extends for miles in every direction. There's no sense of ground, no landmarks, no up or down. The glow becomes both orientation and identity, the only visible sign of existence. For the animals themselves, light might serve as the only connection to others of their kind, the only way to signal across distance. It's hard not to imagine a kind of loneliness there, though loneliness is a human word. Down there, perhaps, the glow is simply presence, the statement, "I am here," made visible. The diversity of bioluminescent mechanisms is staggering. Some creatures use bacterial symbiosis like the anglerfish. Others rely entirely on internal reactions. A few can even absorb light produced by others and re-emit it in different wavelengths. Some jellyfish turn blue light into green, amplifying the effect through special proteins. These same proteins, extracted and studied, revolutionized molecular biology when scientists realized they could be used to tag and trace genes. Every glow in the ocean is a potential discovery, not just of life itself, but of new ways to see it. It's strange to think how the boundaries of our knowledge keep expanding through something so small. A single cell that glows in darkness can change entire fields of science. The creatures that evolved this light didn't do it for us, of course. They've been perfecting it for millions of years, unaware of how we might someday use it. Yet that's what makes the deep so powerful. It contains knowledge that predates our existence, waiting patiently until we learn how to ask the right questions. If you imagine floating there surrounded by these glowing lives, it wouldn't feel like being in darkness at all. It would feel like being inside a slow storm of stars. Some light fades as you approach. Others appear unexpectedly in the distance, like galaxies forming and collapsing in miniature. Every spark is alive. Every flicker has intention. The ocean becomes a kind of sky turned upside down, its constellations swimming instead of burning. The creatures that glow where the sun cannot aren't just surviving, they're creating a universe within one. The machines we send down capture fragments of that spectacle, but they never capture its silence. The light behaves differently when you're there. It doesn't illuminate, it hovers, it pulses and breathes. It doesn't cut through the water sharply like a flashlight. It hangs like mist, soft and impossible to measure. Some researchers describe it as haunting, others as peaceful. The truth is probably both. There's something profoundly moving about seeing life that has turned darkness into its element, not as a condition to escape, but as a canvas to live upon. And perhaps that's why the glow of the deep affects us so deeply when we see it. It reminds us that light isn't ownership, it's expression. The creatures below don't chase it as we do. They generate it as needed, briefly, meaningfully. In that way, they're freer than we are. Their world is darker, but it's also clearer. Everything visible has purpose. Everything illuminated has meaning. The rest can stay unseen without loss. Somewhere far below, at this very moment, a fish is raising its lure in the darkness. A cloud of plankton is drifting, each particle pulsing faintly like a heartbeat. A jellyfish opens and closes its bell, sending ripples of green through the water. These lights won't last long, but they don't need to. The ocean is never completely dark. It's always alive with quiet, deliberate brilliance, shining just enough for those who belong there to see each other, and never quite enough for us to see it all. If light in the deep is a miracle, then sound is its shadow. Where light fails, sound continues. It moves through water like breath through lungs, slow but unrelenting, carrying meaning far beyond sight. The deep ocean may look silent, but it isn't. It's filled with voices, low, steady, overlapping. Some are ancient, some mechanical, some fleeting. But all of them belong to a world that never truly stops speaking. Sound is how the deep ocean thinks. Water carries sound faster and farther than air ever could. It's denser, more cohesive, more patient. A single sound can travel for hundreds, even thousands of kilometers underwater without fading entirely. That's why submarines use sonar, why whales can communicate across entire basins, and why scientists can sometimes hear earthquakes from continents away. The deep is a cathedral of resonance, vast and unending, where every sound lingers long after its source has gone quiet. At the surface, sound scatters easily. Waves break, bubbles form, air disrupts the signal. But deeper down, especially beyond a few hundred meters, the ocean becomes smoother, more uniform, and sound begins to bend and channel. There's a particular layer called the SOFAR channel, short for sound fixing and ranging, where pressure, temperature and salinity balance perfectly to trap sound waves. In that narrow band, audio travels with astonishing efficiency, refracting gently between layers like light in fibre optics. Whales use it. Submarines use it. It's the deep's natural communication line, a kind of invisible highway where information can move endlessly through the dark. If you could listen to the deep, really listen, the first thing you'd notice is that it's never truly quiet. The ocean's soundscape is constant. There's the distant roar of underwater volcanoes, the groaning of tectonic plates shifting beneath the crust, the hiss of bubbles rising from vents, the thud of collapsing cliffs, and the occasional crash of an iceberg carving into the sea. These are the slow geological voices of the ocean's heartbeat. Layered atop them are the sounds of life. Clicks, moans, pulses, crackles. Shrimp snap their claws to stun prey, creating tiny sonic pops that, when multiplied by millions, produce a background crackling like rain on leaves. Whales sing, their calls rolling across kilometres like chants. Fish grind, grunt and thrum to attract mates or defend territory. Even the movement of plankton creates faint vibrations, inaudible to us but felt by creatures evolved to sense them. Then there are the sounds we've brought with us. The hum of ship engines, the ping of sonar, the distant rattle of machinery. Human noise reaches almost every part of the ocean now. It's so pervasive that some scientists refer to it as the anthropogenic fog. To us it might sound faint, but underwater those frequencies travel far. They mix with natural sounds, masking them, confusing animals that rely on acoustic cues to navigate or communicate. Whales have changed the pitch of their songs to be heard over the growing background of ship traffic. Dolphins have adapted their communication ranges. Some species, unable to compensate, simply go silent. In a realm where sound is everything, silence isn't peace, it's displacement. The study of underwater sound, bioacoustics, ocean acoustics, and hydroacoustics has become one of the most revealing tools in modern marine science. Where light and cameras fail, sound continues to map, measure, and interpret. Scientists deploy hydrophones, underwater microphones, that can record everything from whale calls to the hum of distant earthquakes. Arrays of them spread across the sea floor, forming listening networks that monitor not only life but geology, climate, and human activity. These instruments have detected sounds no one expected. Mysterious low-frequency pulses known as the bloop, rhythmic thuds that echo across thousands of kilometres, and sharp crackles from icebergs breaking apart. Each new sound adds to the vocabulary of the sea. For the longest time we imagined the ocean as mute. The early explorers descending in small submersibles often described an eerie stillness. But that was illusion, the silence of human ears, not of the environment. Our senses aren't built for underwater hearing. In air, we detect sound by pressure waves hitting our eardrums. Underwater, the density mismatch between body and medium makes that mechanism inefficient. Most marine animals bypass this entirely, feeling vibration through specialized organs or even through their bones. They hear with their entire bodies. To them, the ocean isn't silent, it's alive with information. Some of the most haunting sounds in the deep come from the largest inhabitants, whales. Their songs travel farther than any other biological sound on Earth. A blue whale's call, for instance, can be heard across entire ocean basins. It's a sound so low in frequency that much of it lies below human hearing, more felt than heard, a vibration that moves through you rather than around you. To imagine it is to imagine the sound of a planet breathing. These calls aren't random, they're structured, with patterns that change by region and year, suggesting both communication and culture. Some species repeat melodies that evolve over time, passing through populations like folk songs. To study them is to glimpse not just biology, but something that approaches memory. Whales aren't the only composers of the deep. Fish too have their rhythms. The midshipman fish, for example, hums to attract mates, producing a low, sustained drone that can last for hours. In coastal areas, When many individuals sing together, the result is a steady vibration that can be felt through the hulls of boats. Scientists have recorded entire soundscapes shifting with the lunar cycle, as species adjust their behaviour with the tides. It's an ecosystem orchestrated not by sight, but by resonance. The deep sea amplifies this strangeness. Down where light cannot reach, sound becomes the only reliable medium. Some fish emit sharp clicks that bounce off objects, using echolocation like bats. Others produce pulses to signal distress or deter predators. There are shrimp that can generate bubbles that collapse with explosive force, briefly reaching temperatures hotter than the surface of the sun. It's called cavitation, a flash of energy so quick that it produces both light and sound. The ocean's darkness hides many things, but its silence hides none. Sound in the deep also carries distance differently than we expect. On land, sound fades quickly. In water, it bends, refracts, slows. A noise made miles away might arrive seconds or minutes later, warped by pressure and temperature layers. To an untrained ear, it would be impossible to locate the source. But marine animals are experts at interpreting these distortions. Some whales can detect the curvature of the earth through sound alone, using subtle delays and echoes to orient themselves. For them, the world isn't divided into near and far. It's a continuous medium of vibration. Humanity's use of sound underwater began with curiosity, then strategy. During the early 20th century, navies developed sonar to detect submarines, sending out pings and measuring the echoes that returned. Those same principles later became scientific tools. Multibeam sonar now maps the seafloor with astonishing precision, revealing valleys, ridges and trenches we could never see otherwise. But the technology that helps us explore also intrudes. Powerful sonar pulses can disorient marine mammals, sometimes driving them to strand themselves in confusion. What we use to see in the dark can also blind the creatures that already live there. The deep is generous with sound, but it demands care in how we use it. When hydrophones record the ocean for long stretches, what emerges is not chaos but rhythm. The earth itself has cycles of sound. Seasonal changes alter the chorus of life. More crackling shrimp in summer, more whale calls in migration seasons, fewer fish during winter dormancy. Even storms above leave their mark, with raindrops and wind creating patterns that filter down. Underwater, you can hear weather. You can hear the signature of hurricanes as low-frequency rumbles that travel for thousands of kilometers. You can hear icebergs breaking, their fragments ringing like bells as they drift. It's all connected, one continuous conversation between sky, sea, and stone. There's something humbling in realizing that sound can do what light cannot, unite the planet's hidden places. A single signal in the SOFAR channel might travel from one hemisphere to another, carrying traces of life and movement across entire oceans. It's as if the Earth is wired for listening, its waters serving as both body and voice. Scientists who study these sounds sometimes describe them in musical terms: crescendos, harmonics, echoes. It's not poetry, it's physics. But the physics has its own beauty. If you were inside a deep-sea submersible and switched off the engines, you might expect silence. Instead, you'd hear a subtle chorus, distant clicks, slow groans, the occasional metallic ring as the hull adjusts. It would feel less like being alone and more like being surrounded by something immense but calm. Every noise would seem both close and far at once. That sensation, the blending of near and infinite, is what defines the ocean's sound. It's a world where location dissolves, where everything exists in relation to everything else. Over time, researchers have learned to read this language with precision. They can identify specific whale species by their calls, estimate fish populations by the volume of their choruses, even detect illegal fishing activity by the sound of boat engines. Some deep-sea monitoring systems now listen continuously, forming a kind of acoustic memory of the planet. Decades from now, scientists may be able to track environmental change not by photographs or samples, but by shifts in sound. The deep ocean's voice could become its own archive, a living record of climate, biology, and human presence. The idea that sound defines this world changes how we think about exploration. We've spent centuries chasing visibility, wanting to see, to photograph, to illuminate. But in the deep, seeing is a privilege, hearing is survival. For most creatures there, vision is useless or non-existent. Instead, they live in a constant awareness of vibration, pressure, and tone. The ocean doesn't ask to be seen, it asks to be heard. Listening to it has taught us not just about marine life, but about the Earth itself. Hydroacoustic data have revealed previously unknown volcanic eruptions, landslides, and meteor impacts. They've recorded the rumble of undersea earthquakes hours before the resulting waves reach shore. In that sense, sound isn't just a window into the deep. It's an early warning, a messenger. The ocean tells us what's happening if we're quiet enough to hear it. But quiet is the hardest thing for humans to achieve. The deeper we go, the more we bring with us. Motors, propellers, drills, cables. Even our listening devices make noise. We try to hear, but we keep interrupting ourselves. To truly understand the deep, we would need to learn to enter it without speaking, to let it talk first. The sound of the deep doesn't need amplification. It needs attention. There are recordings from the deepest hydrophones placed miles below the surface that capture a kind of subsonic hum, a low continuous vibration present everywhere. Some researchers call it the ocean's background tone, others the sound of the Earth itself. It isn't caused by any single source, but by the collective motion of waves, tides, and distant storms. It's the sound of movement on a planetary scale, constant and ancient. Listening to it feels like eavesdropping on the planet's breathing, slow and patient. When you think about it, it makes sense that the deep communicates through sound. Light fades in minutes, but sound endures. It bends, adapts, and travels through obstacles. It's resilient, like life itself. In the deep ocean, where conditions change faster than visibility allows, sound provides continuity. It's how everything stays connected in a place too vast for sight. Imagine floating there, surrounded by darkness, hearing instead of seeing. You wouldn't know direction, but you'd know presence. Faint clicks, distant echoes, low murmurs that vibrate through the water into your bones. It wouldn't be noise, it would be awareness. The deep doesn't need light to communicate its existence. It does it through resonance, through the endless patience of sound. When we talk about the deep ocean, it's easy to forget that every measurement, every image, every small success exists because someone, somewhere, decided to face what the human body was never meant to endure. We often describe the ocean's depths in scientific terms: pressure, temperature, light. But at its heart, it's also a mirror that shows us our fragility. The further we go, the more those limits define us. In a world shaped entirely for water and weight, the human body is a misplaced design, a land dweller's attempt to borrow time in an alien atmosphere. Down there, beneath the blue surface that looks so inviting from above, every breath becomes borrowed, every heartbeat conditional. The body that thrives in air becomes strange in the sea. Our lungs, built for lightness, betray us in density. Our ears, tuned to thin air, fill with pressure. Our blood, so carefully balanced between gases and liquids, starts to dissolve the very oxygen that keeps us alive. We are creatures of one atmosphere, of gravity unfiltered. The ocean, patient and absolute, reminds us of that with every metre we descend. 10 metres below the surface, we feel twice the pressure of the air above us. At 100, 10 times. Beyond that, the numbers become meaningless. But the body doesn't need numbers to understand. It feels the change as a kind of deep, internal silence, a quiet that grows heavier with every breath. Divers know this silence well. They describe it not as fear, but as awareness. Every descent is a negotiation between will and physiology. The deeper they go, the more they learn to listen, to their heartbeat, to their breathing, to the soft creak of their own equipment. At first, the pressure feels like a presence, a soft squeeze around the chest and ears. Then it becomes part of the background, something to be accepted rather than resisted. But there's always a point where acceptance ends and survival begins to falter. Past a certain depth, the gases in our blood start to behave differently. Nitrogen, which is harmless on the surface, dissolves more readily under pressure, affecting the nervous system. It creates a dreamlike state, euphoric and disorienting. Divers call it the rapture of the deep. It feels peaceful, but it's deadly, a false comfort that leads to confusion, slow reactions and sometimes fatal mistakes. Even oxygen, the molecule we depend on most, becomes toxic under enough pressure. The body cannot tell the difference between too little and too much until it's too late. Cells begin to break down, nerves misfire, vision narrows. The very substance that sustains us becomes poison in the wrong conditions. The deeper you go, the thinner the margin of safety becomes, until survival depends not on strength but on discipline, knowing when to stop, when to turn back, when to trust the quiet voice of instinct that says, enough. But the ocean is persuasive. It tempts with calm, with beauty, with the illusion of control. Divers describe the moment when light fades as transcendence, the sense of entering another reality entirely. The water becomes still, the sound of breathing rhythmic, the mind focused. For a moment, the boundary between body and world blurs. It's easy to forget how thin that boundary really is. A malfunctioning valve, a small leak, a few seconds of disorientation, that's all it takes. Down there's no margin for panic. Panic wastes oxygen, and oxygen is measured in minutes. The deeper we send our machines, the more we understand how delicate we truly are. The pressure that dents steel would crush us instantly. The cold that seeps through titanium would paralyze us in seconds. The dark that surrounds every deep-sea creature isn't just absence of light. It's a thickness that seems to erase edges, distances, even thought. Human senses begin to fail long before the body does. Our vision fades, our hearing becomes unreliable, our balance shifts. Inside a submersible, even with walls meters thick, you can feel it. The sense that something immense is pressing against the thin boundary between you and oblivion. It's not fear in the usual sense. It's awareness of scale. The realization that you're a small organism floating inside a bubble of technology, inside a volume of water so vast it defies imagination. The deep ocean doesn't care that you're there. It doesn't even notice. Everything about it, pressure, chemistry, stillness, continues as it has for millions of years, indifferent to human presence. The fragility you feel in that moment isn't weakness, it's truth. You're out of your element, surviving only because of layers of invention and luck. And yet, fragility has always been part of what drives us. It's the reason we build, the reason we explore. We know we're vulnerable, and we reach anyway. When early divers first began descending with crude equipment, many died trying to understand how far they could go. Their courage wasn't in defying danger, but in accepting that danger was the price of knowledge. Every dive became an experiment in limits, of body, of breath, of will. Even now, with advanced suits and controlled breathing mixtures, accidents still happen. Oxygen runs out, decompression schedules fail, equipment jams. Sometimes it's human error, sometimes it's chance, but the outcome is the same. The deep reminds us who's in charge. The human body is designed for balance, equal pressures inside and out, steady warmth, stable chemistry. The ocean disrupts all of that. The cold slows metabolism. The pressure compresses air spaces. The salt draws moisture from skin. Even small changes can cascade into crisis. A diver who surfaces too quickly after a deep dive risks decompression sickness, known as the bends. It's caused by dissolved gases forming bubbles in the blood as pressure drops. The pain is severe. But the danger is worse. The bubbles can block circulation, cause paralysis, even death. The cure is to return to pressure, to descend again, slowly, so the body can recover. There's a cruel symmetry to it. The same depth that nearly kills you becomes the only thing that can save you. For those who descend in submersibles, the experience is different but not less humbling. Encased in thick metal walls, you're protected from the crushing weight, but not from awareness. The hull creaks as the pressure increases, small groans that sound like distant thunder. Every sound echoes through the chamber, amplified by the knowledge of where you are. There's nowhere to go, nowhere to run, only trust, in engineering, in preparation, in the quiet competence of those who designed this fragile sphere. The line between safety and catastrophe is measured in millimeters of steel. Some explorers describe the sensation of deep descent as meditative, almost sacred. The surface world disappears, no light, no sky, no horizon, and what's left is focus. You're suspended in black water, moving downward at a few meters per second, watching the numbers climb on the pressure gauge. It feels endless. You know that the smallest mistake could be fatal, but that awareness sharpens rather than dulls the mind. In that state, fragility becomes clarity. It reminds you that control is never total, that every heartbeat is borrowed from an environment that doesn't belong to you. Even for those who never dive, the fragility of the human body shapes how we explore. We build layers of technology to compensate for our limitations: pressure hulls, oxygen systems, navigation computers, communication arrays. But each of those layers adds new points of failure. Complexity becomes both salvation and risk. Every dive plan, every research mission is a calculated balance between ambition and restraint. You can only push so far before the ocean pushes back. The deep doesn't forgive arrogance, it rewards humility. Engineers who design deep-sea equipment talk about redundancy, the practice of building backups for every system. 2 oxygen tanks, 2 pumps, 2 power sources, but even redundancy has limits. When a system fails miles below the surface, rescue is rarely an option. The only safety lies in prevention, in precision, in respect for physics. The sea doesn't bend its rules. You either follow them or you don't return. The deeper we go, the more we understand that fragility isn't something to overcome. It's something to work with. It teaches us how to measure risk, how to build carefully, how to listen. It's easy to imagine fragility as weakness, but in truth, it's the foundation of awareness. The pressure outside mirrors the pressure inside. The quiet tension that comes from knowing how small you are and how rare it is to survive in a world that wasn't made for you. Some explorers come back from deep dives changed. They describe a kind of stillness that lingers long after the mission ends. It's not trauma or awe exactly, it's perspective. When you've seen the world from a place where life struggles just to exist, everyday fragility feels different. The small stresses of surface life, noise, deadlines, expectations, shrink against the memory of that immense quiet weight. Down there, you don't think about the future or the past. You think about air and warmth and the astonishing fact that the body still works. That awareness doesn't leave easily. Fragility also extends beyond the body. It's part of the human mind. The ocean tests not just lungs and blood, but focus and resolve. Isolation in the deep can blur time. Without daylight, circadian rhythms break down. Inside a submersible, hours stretch and compress unpredictably. You can lose track of how long you've been below, how far you've travelled. It's disorienting, but also strangely freeing. In that darkness, the idea of self feels less fixed. You begin to sense that consciousness itself is fragile, a pattern held together by light and gravity and habit. Remove those, and it starts to drift. This mental fragility isn't weakness either. It's part of what allows us to adapt. Humans are soft by design. We're built to feel, to notice, to respond. The ocean amplifies those traits. It turns awareness into survival. A diver who ignores discomfort risks death. A pilot who doubts data loses the mission. A researcher who forgets patience destroys the equipment. Fragility forces mindfulness. It demands presence. The ocean doesn't tolerate distraction. In that way, fragility becomes its own form of strength, not resistance, but sensitivity. We survive not because we're unbreakable, but because we know how to bend, how to adjust, how to retreat when needed. The deep teaches that lesson better than any classroom. It shows that survival isn't about dominance. It's about equilibrium. Every creature that lives down there has found its own balance between vulnerability and resilience. We're just beginning to learn the same. Every time a human descends into the deep, whether in a diving suit or a submersible, it's an act of quiet defiance against biology. But it's also an act of recognition that the limits of the body are not flaws, but boundaries that define experience. Without them, there would be no sense of wonder, no respect for danger, no reason to build or explore. Fragility gives meaning to endurance, and maybe that's why the deep ocean fascinates us so much. It's not just the mystery of what lives there, it's what it reveals about ourselves. The realization that we are temporary guests in a universe built for pressure and silence. The machines may survive longer, the sensors may reach farther, but it's the human heartbeat, faint and fragile, that makes exploration matter at all. The deep doesn't need us. It has existed in darkness for eons without our eyes or ears, but we need it, because it reminds us of proportion, that to be alive is to be delicate, that strength is measured not by invincibility but by endurance. The ocean shows us that fragility and courage are the same thing, two sides of the same thin shell keeping life where it shouldn't logically exist. And as that shell descends, as it creaks and holds under impossible weight, we learn again what it means to be human, to survive, to listen, and to keep moving deeper, knowing full well that the body we inhabit was never built for the dark. Beneath the endless dark, where light and sound fade into the pressure, there are shapes on the ocean floor that resemble memory more than geography. The deep doesn't just hold life, it holds the past. The seafloor is a museum without walls, a place where time slows until it almost stops. What lies there isn't only biology or geology, it's the silent record of everything that has fallen from the surface, from broken continents to forgotten ships, from volcanic peaks to drowned coastlines. The deeper you look, the more it feels as though the planet has been layering its own history into sediment, letting gravity and water archive what we can't remember. The idea of sunken cities sounds like myth. For centuries, people imagined entire civilizations lost beneath the waves. Atlantis, Mu, Lemuria, names that became shorthand for mystery and pride. But while those specific legends remain stories, their foundation is truth. The sea has taken cities before. The Earth's surface is restless, and the line between land and water is not fixed. Coastlines advance and retreat, mountains rise and crumble, ice melts and reforms. The ocean is patient, and over time it always wins. It erases borders quietly, metre by metre, until what was once home becomes seabed. If you were to drain the oceans completely, what would appear would look nothing like the maps we know. The continents would stretch farther but also fracture into scars. The Atlantic would reveal a vast ridge, the mid-ocean seam where new crust forms from molten rock, constantly reshaping the floor. The Pacific would open into trenches so deep they look like slashes, where tectonic plates dive beneath one another. Between them would lie plateaus, canyons, valleys, mountains taller than Everest that no one has ever seen in person. Some of those peaks are ancient volcanoes, long extinct. Others still breathe, releasing heat and minerals that feed entire ecosystems. Among those peaks and plains are the remnants of worlds that used to be above water. The Black Sea, for instance, was once a freshwater lake surrounded by early human settlements. Around 7,500 years ago, as the last ice age ended and global sea levels rose, the Mediterranean spilled over a narrow land bridge, flooding the basin in a catastrophic surge. Villages, forests, and fields vanished almost overnight. Archaeologists have found evidence of human tools and dwellings hundreds of meters below the modern surface. A reminder that climate change is not new, only newly witnessed. The ghosts of those drowned communities still lie buried in silt, their stories muted by salt and time. Farther south, along what is now India's coast, sonar has revealed the outlines of structures beneath the Gulf of Khambat, geometric patterns that suggest walls, streets, and foundations. The discovery sparked debates: ancient civilization or natural formation. The ocean doesn't clarify. It preserves shapes but not certainty. Sand and current distort everything, blending human order with geological chance. Whether those patterns belong to cities or stones hardly matters. They show that the boundary between myth and evidence is as fluid as the tide itself. All along the continental shelves, traces of lost landscapes wait in silence. Beneath the English Channel, scientists have mapped an ancient river valley called Doggerland, a land bridge that once connected Britain to mainland Europe. 10,000 years ago it was grassland filled with herds and forests. Now it's fishing ground, its hills and rivers buried beneath silt. Divers have recovered bones of mammoths and tools of hunter-gatherers from its seabed. Every tide that moves across it carries fragments of a vanished world. These aren't ruins in the way we think of ruins. No standing walls or columns, no mosaics or temples. They're impressions, preserved in mud and stone. The ocean doesn't freeze time, it reworks it, layering history under new sediment. That's why so much of Earth's memory belongs to the deep. Once the sea takes something, it stops decaying in the usual way. Oxygen disappears, microbes slow down, corrosion becomes glacial. Objects buried there can last thousands of years untouched. Wooden shipwrecks rest in near-perfect condition, their hulls intact, their cargo still packed as it was. The cold, the pressure, the dark, the same conditions that make exploration impossible also make preservation perfect. Shipwrecks are perhaps the most haunting examples of these silent ghosts. Every ocean holds them. Thousands of steel and wooden skeletons lying on the bottom, each one a frozen story of human ambition meeting physics. Some are modern vessels, swallowed by storms or war. Others are centuries old, resting under layers of silt. The Titanic, resting nearly 4 kilometers down in the North Atlantic, is the most famous, but it's only one among countless. Its hull still lies there, colonized by bacteria and corals, slowly dissolving but still recognizable. The iron-eating microbes feeding on it will eventually erase it completely, but for now it remains as both monument and warning, a reminder of how fragile even our greatest achievements become under the weight of water. There are wrecks deeper still, submarines lost during wars, cargo ships that disappeared without radio contact, aircraft swallowed by waves. Each one joins the same quiet company, transformed from tragedy into geology. The ocean doesn't distinguish between natural and artificial. To it, a coral reef and a steel ship are the same kind of structure. Surfaces to colonize, cavities to fill. Life moves in. Fish nest inside cabins. Barnacles coat the walls. Coral spreads across decks. Over time, every wreck becomes reef. The ocean turns death into habitat. But not all of its ghosts are human. There are also mountains that never saw daylight, volcanoes that erupted unseen, valleys where rivers once flowed before the sea claimed them. Some of these formations predate humanity entirely. The Hawaiian Islands, for example, are just the visible tips of a much larger chain that stretches thousands of kilometers along the Pacific floor. Each island represents a moment in geological time, born from a volcanic hotspot that keeps moving as tectonic plates shift above it. The older mountains lie submerged, their peaks eroded and buried, their bases still connected to the living Earth's molten pulse. The seamounts and guyots that scatter across the ocean floor are monuments to that slow movement. Mountains drowned not by catastrophe, but by time. There are also the deep trenches, the silent mountains turned inside out. The Mariana, the Tonga, the Java, immense scars where the crust folds under itself. These are the deepest points on Earth, colder than winter, darker than space, and as still as eternity. If you could stand at the bottom of one of them, impossible for the human body but imaginable through machines, you would see walls rising like cliffs into darkness, the floor dusted with fine sediment, occasional rocks coated in white bacterial mats. It's a world of immense pressure and absolute quiet. The mountains here are negative, inversions of the ones we climb. They rise upward into absence instead of air. The geological forces that sculpt these landscapes operate on scales we can barely comprehend. Tectonic plates drift a few centimetres a year, yet over millions of years they reshape continents. Entire mountain ranges rise and vanish without witnesses. The Himalayas were once seabed. Fossils of marine creatures have been found near their peaks, proof that what we call permanent is only temporary in geological terms. The ocean floor, too, is constantly being recycled. New crust forming at ridges, old crust sinking into trenches. The ground beneath the deepest sea is younger than the rocks beneath our feet. Even the ancient ghosts there are part of something that's still moving, still changing. Sometimes, when submersibles capture footage of these places, it's almost impossible to believe they're real. Vast plains of black basalt stretch to the horizon. Towering cliffs rise out of darkness, their edges lost in shadow. Chimneys of hydrothermal vents pour mineral-rich water into the cold, glowing faintly from chemical reactions. The footage looks alien, but it's home, the unseen part of our planet that shapes everything above. Earthquakes, tsunamis, volcanic eruptions, all begin in these hidden mountains and valleys. The deep isn't just history, it's the engine of now. And among these silent formations, among the remnants of ancient seas and drowned lands, lie traces of our own age, cables, debris, containers, fragments of technology. The ocean floor has become a map of human presence, unintentional but undeniable. Communication lines stretch like artificial routes across continents. Lost cargo spills from ruptured ships, scattering plastic and metal across silt. It's ironic that even as we fail to explore the deep fully, we've already left our fingerprints there. Our fragility travels downward too. When scientists study the sediments at the bottom of the ocean, they find more than natural minerals. They find microplastics, heavy metals, radioactive isotopes, the signatures of modern civilization. These layers will one day become strata in the geological record, marking the moment when humanity became part of Earth's deep memory. We may never build cities down there, but in a way we've already left our ruins. Still, the ocean remains the ultimate archaeologist. It takes everything, but it gives back understanding. By studying the layers of sediment, scientists can read climate history stretching back millions of years, changes in temperature, atmospheric composition, even mass extinctions. Each centimetre of mud holds centuries of information. The deep is not just a graveyard, it's an archive. And like all archives, it speaks slowly, requiring patience to interpret. Every now and then, a discovery pierces that stillness. A submerged temple off the coast of Japan, an ancient ship unearthed by a storm, a city uncovered by sonar where no one expected one. Each of these moments reminds us that the line between the living world and the buried one is thin. The ocean's ghosts aren't gone, they're simply out of reach. They wait, preserved and distant, as if the planet itself were keeping secrets until we're ready to understand them. The mountains beneath the sea, the ruins buried in silt, the wrecks resting in silence. They all share the same quality. They don't move unless the earth itself moves them. They endure without needing attention. They exist outside of urgency, untouched by the passing of days. In their stillness, they remind us of how temporary the surface world really is. Our cities, our towers, our roads, all of it is one flood, one earthquake, one rising tide away from becoming part of that same quiet record. It's not a warning so much as a perspective. The ghosts of the deep aren't tragic, they're inevitable. They show what happens when time is allowed to continue without interruption. The sea doesn't mourn what it covers, it integrates, it turns memory into matter. That transformation is its nature. If you could walk across the sea floor, through the valleys and over the mountains, past the wrecks and the fossilized corals, you'd see the planet as it truly is. Not a static sphere, but a living body, shedding and rebuilding itself continuously. Every ridge, every trench, every buried structure is a trace of that motion. The deep isn't death, it's transition, written in stone and salt. Somewhere far below, beyond the reach of light or time, a mountain is rising from molten rock, and beside it, another is sinking into the crust. Above them, pieces of history drift downward, fragments of ships, bits of plastic, the dust of civilizations. They settle quietly, joining the same long conversation that the planet has been having with itself since before we were here. The ghosts of sunken cities and silent mountains are not echoes of loss. They're reminders that nothing ever truly disappears. Everything sinks eventually, into memory, into sediment, into the slow patience of the sea. And while we watch from the surface, the deep keeps writing its story, layer by layer, in the language of pressure and time. When sight disappears, imagination takes its place. The deep ocean has always been a perfect mirror for that. Long before we could measure pressure or send cameras beneath the waves, we filled that darkness with stories. Sailors saw shadows on the water and gave them names. Cultures separated by continents described the same fears in different tongues, the same sense of something vast and unseen just beyond reach. In the absence of light, myth became a kind of navigation. It helped humanity find meaning in a world that refused to show its face. It's strange how consistent those myths are across time and distance. From the earliest civilizations, the sea was never just a boundary, it was a presence. The Greeks imagined it ruled by gods who reflected its moods, calm one day, furious the next. To them, the ocean wasn't chaos but personality, unpredictable yet aware. In the Pacific, island cultures spoke of the sea as a living ancestor, a force that gave life and demanded respect. Norse legends describe serpents so large they could encircle the world, sleeping beneath waves that rose and fell with their breath. Ancient Chinese texts spoke of dragons dwelling in deep waters, keepers of weather and fate. These weren't primitive attempts to explain science. They were expressions of proportion. The ocean was so enormous, so alive, that the human mind could only meet it with story. Every myth was an acknowledgement of scale, the understanding that something could exist beyond our comprehension. The creatures that populated those tales weren't mistakes. They were metaphors for magnitude. The kraken, the leviathan, the world serpent. Each one was a way of saying, there are forces beneath us that do not care who we are. Even today, those stories haven't gone away. They've just changed costumes. The names are different, but the impulse is the same. We invent monsters for the same reason our ancestors did, to give shape to uncertainty. Modern myths live in headlines and documentaries now, dressed in scientific speculation. The giant squid, once a sailor's nightmare, turned out to be real, and even its reality feels mythical. The coelacanth, thought extinct for millions of years, appeared alive off the coast of South Africa, defying extinction like a ghost from prehistory. Each rediscovery blurs the line between imagination and evidence. The deep doesn't reject myth, it recycles it. There's something in the human mind that resists pure emptiness. Darkness is never just darkness, it's potential. We project into it, populating the unknown with our hopes and fears. That's why the deep ocean feels different from a mountain or a desert. It's not merely unexplored, it's unseeable. No matter how advanced our technology becomes, it will always be a place where sight fails. And where sight fails, the imagination grows strong. That's not superstition, it's instinct. For as long as there's been a horizon, humans have wondered what lies beyond it, and the sea was our first horizon. Myth filled that distance with possibility. It gave shape to what couldn't be mapped. When sailors vanished, people didn't say they sank. They said the sea took them. When storms appeared out of nowhere, they were blamed on creatures stirring in the depths. The human need for cause and consequence turned weather into intention. We gave the sea motives so we could feel less powerless against it. It's easier to fear a monster than to fear randomness. Monsters can be understood. Chaos can't. But the deeper truth behind these myths is quieter. The sea has always represented not just fear, but memory. Many cultures saw it as a boundary between worlds, the realm of the living and the dead, the known and the forgotten. In Japanese folklore, spirits of the drowned linger beneath the surface, whispering to fishermen. In Polynesian traditions, the ocean is both cradle and grave, a place where souls return to rest. Even in modern stories, the ocean remains the setting for disappearance. We still talk about things being lost at sea, as if the water itself has intentions, as if to vanish there is to enter another dimension of existence. What's fascinating is how myth evolves alongside discovery. Each time we descend deeper, we replace one story with another, but we never stop telling them. When submarines first reached the twilight zone, their pilots described seeing shapes move outside the light beams. Shapes too large to identify, too graceful to be debris. Some of those reports turned out to be schools of fish. Others remain unexplained. The footage we do have from the deep often leaves more questions than answers. Creatures appear briefly, flash with light, and vanish into darkness. It's not hard to see why the imagination fills in what the camera misses. Even scientists, though careful with language, speak of the deep with reverence that borders on mythology. They use words like alien, mysterious, and otherworldly, terms that reveal as much about human emotion as they do about fact. The deep ocean resists domestication. No matter how much data we gather, it refuses to become familiar. It's as though the planet keeps one realm deliberately unknowable, a reminder that knowledge has edges. In that way, myths serve an unexpected purpose. They protect mystery. They remind us that not everything needs to be understood to be meaningful. Some of the earliest ocean legends were not warnings of danger, but lessons in humility. The sea, they said, belongs to itself. You may cross it, harvest it, even live beside it, but you never own it. Every culture that survived near water learned that truth. The moment you forget it, the sea takes it upon itself to remind you. And perhaps that's why myths about the deep are never just about monsters. They're about relationship, between surface and depth, life and death, control and surrender. The creatures in those stories are reflections of us, distorted by distance and fear. When we imagine a leviathan coiled around the world, we're really describing our own scale against the planets. When we tell stories about cursed voyages or ghost ships, we're grappling with the limits of human certainty. Every myth about the sea is also a confession. We know less than we like to believe. Over time, science has taken the place of folklore, but it hasn't erased the impulse behind it. The ocean still inspires awe in ways that science alone can't contain. A biologist looking at a deep-sea jellyfish might describe its anatomy, its feeding behaviour, its genetics. But the first reaction, before the data, is always wonder. That feeling, the shock of beauty, the recognition of something alive yet utterly alien, is the same feeling that gave rise to myth. The names and explanations change. but the emotion is ancient. Even our most rational language reveals this continuity. We call certain creatures monsters of the deep, not because they're evil, but because they're outside our frame of reference. We describe them as strange, grotesque, or unbelievable, when really they're just honest expressions of an environment that doesn't care about our aesthetics. The blobfish, the gulper eel, the giant isopod, all perfectly adapted to their world, all mocked or marvelled at in ours. The myth persists because the boundary between fascination and fear is thin. In some ways, modern myths have become quieter. We don't imagine gods under the waves anymore. We imagine data waiting to be discovered. But even that faith in discovery, in explanation, is its own kind of myth. We tell ourselves that technology will eventually reveal everything, that there's no mystery that can't be solved. The ocean disagrees. It hides 95% of its volume from human eyes, not maliciously, but naturally. It remains, as it always has, too big for ownership, too complex for closure. Some of the old legends, when you look at them closely, contain more wisdom than superstition. The Polynesian navigators who crossed vast distances without maps relied on a deep, intuitive understanding of the sea. They could read waves, currents, and stars with precision that modern instruments have only recently matched. Their myths about ocean spirits weren't just beliefs, they were frameworks for respect and discipline. To navigate safely, you needed to treat the sea as something conscious, not literally, but ethically. That mindset kept them alive. Even in the West, where the Enlightenment replaced spirits with measurements, the ocean kept its mythology. Artists and writers turned it into metaphor, for the subconscious, for time, for infinity. Melville's whales and Coleridge's albatrosses are modern descendants of old gods. They show how myth adapts to each era's language. The same awe that once filled temples now fills laboratories and studios. The medium changes, the meaning endures. What makes the deep ocean unique among all earthly places is that it remains resistant to domestication. We've charted mountains, mapped the moon, and built machines that can orbit the planet, but we still speak of the deep as if it were another world. That persistence of mystery ensures that myth will always have a home there. Each discovery adds detail without dissolving the unknown. Every new creature filmed by a submersible becomes both explanation and continuation of a wonder. Sometimes, when researchers review footage from unmanned dives, they find anomalies, lights flickering in patterns that don't match bioluminescent organisms, shadows moving against current. Usually there's a rational explanation, reflections, distortions, debris, but not always. And in those not always moments, the imagination wakes up again. The scientists smile quietly, the same way ancient sailors might have whispered about sea serpents. They don't believe in monsters, but they believe in mystery which is close enough. The myths that fill the darkness don't live in opposition to science, they live beside it. They give context to our curiosity. Without them, exploration would feel empty, reduced to data collection. With them, it becomes narrative, a story of human persistence against uncertainty. Every sonar ping, every sample, every recorded sound from the deep adds a new line to that story. We may not speak in mythic language anymore, but the structure remains. The journey into the unknown, the encounter with something vast, the return with new understanding. The deep ocean is our last functioning myth in real time, one that keeps renewing itself as long as we keep asking what lies below. And maybe that's the real reason the ocean has never lost its hold on us. It isn't just the beauty of the surface or the richness of life beneath. It's the sense that somewhere down there, in the dark, something is still beyond explanation. Not sinister, not supernatural, just beyond. The myths that fill that space aren't mistakes. They're reminders that even now, in an age of maps and satellites, there are still places where imagination remains necessary. The sea doesn't ask us to believe in monsters, It asks us to accept mystery. And somewhere, beyond the reach of light, those stories continue. Not written, not spoken, just drifting through the dark water, as old as fear, as familiar as curiosity, waiting quietly for whoever dares to listen next. If the myths that fill the darkness were born from our imagination, then the eyes that now stare back from that same darkness are the instruments we built to replace it. For as long as there has been curiosity, humans have wanted to see what lies beneath the surface, to look, not just to imagine. But the ocean makes that act almost impossible. It hides not out of malice, but through physics. The way light bends, the way water absorbs colour, the way depth multiplies in visibility. Seeing in the deep is not a natural act. It's an intrusion, an attempt to translate a world that never evolved to be witnessed. And yet, we've tried. Every deep-sea expedition begins with the same desire, to turn darkness into sight. Our eyes were never meant to see there, so we built new ones, cameras, lenses, sensors, machines that could survive pressure, endure cold, and capture light too faint for biology. The first attempts were crude. Glass portholes on steel spheres, lights bolted to frames, cables running back to ships above. The images they brought back were grainy, distorted, almost abstract, but they were proof that visibility was possible. For the first time, humanity could look directly into the midnight zone, and what it saw was both thrilling and humbling. Not monsters or emptiness, but a vast stillness punctuated by movement so slow it bordered on silence. Those early eyes were mechanical extensions of human will. They didn't know what to look for, so they recorded everything. The footage often showed small particles drifting past the lens, mistaken at first for snow, then later understood as marine snow, a rain of organic material falling endlessly from the surface. Dead plankton, fecal matter, fragments of algae and shells, all descending like dust through water. It became clear that this slow fall was what fed the deep. Every spark of life there depended on it. The first eyes in the abyss revealed not horror or chaos, but order, a cycle of decay and renewal happening in perpetual twilight. The more our technology improved, the clearer those images became. Fibre optics replaced steel cables, digital sensors replaced film. Autonomous submersibles began to carry high-definition cameras capable of operating for weeks without human control. They moved through the dark with precision, their beams slicing narrow cones of light through blackness. What those beams revealed wasn't emptiness, but a living universe of subtle colour and movement. Shrimp the size of grains drifted beside jellyfish longer than cars. Fish with transparent heads floated motionless, their eyes rotating inside domes of glass-like tissue. Everywhere, there were signs of adaptation, creatures shaped not by sunlight but by the absence of it. The cameras recorded what no human eye could directly perceive, light that isn't light as we understand it. In near total darkness, bioluminescence becomes the dominant language. Creatures flash and pulse, some constantly, others in rhythm. The first time these displays were filmed, scientists compared them to constellations, tiny galaxies drifting through liquid night. The recordings were more than beautiful, they were revelations. They showed that the deep wasn't barren, as once thought, but densely populated. Its life was delicate, translucent, often invisible to anything but the most sensitive instruments. Our eyes had been too blunt to see it. The abyss had always been alive. We just hadn't learned how to look properly. But the act of looking changes what is looked at. Every expedition wrestles with that paradox. The lights needed to film these creatures can also blind or disorient them. The machines that hover silently are in truth never silent. Their thrusters hum, their electronics click, their beams cut through the dark like intruders. To observe the deep is to disturb it. Even the softest light is violence to eyes that evolved to live without it. Some researchers have tried to adapt using infrared or low-intensity blue light, trying to become invisible to the world they're studying. Yet invisibility is impossible. The abyss always knows when it's being watched. There's a quiet irony in that. Our instruments have become so sophisticated, yet they still betray us. Cameras can now see wavelengths our eyes never will, detect heat and chemical traces, sense movement at distances too small to comprehend. But even with that precision, the act of perception is incomplete. The cameras can record what happens, but they can't translate it into meaning. They can't explain why a creature glows or dances or drifts. They only deliver evidence, leaving interpretation to the minds that built them. The abyss gives us images, not answers. Some of those images border on the surreal. A jellyfish shaped like an umbrella with electric blue filaments that flash in sequence. A fish whose mouth folds open wider than its own body. A colony of siphonophores stretching longer than a blue whale, glowing faintly as it drifts through a current. Each new discovery shifts the limits of imagination. The eyes in the abyss show us that evolution has no aesthetic, only function. What looks strange to us is simply appropriate to its environment. Every grotesque shape, every translucent body, every unrecognizable motion is the solution to a problem we can't fully perceive. Still, the footage stirs something beyond curiosity. Watching it, you realize how rarely we encounter life without reference to ourselves. On land, every ecosystem has been touched, mapped, catalogued, or altered. In the deep, life remains indifferent to us. It neither hides from nor approaches. It exists in parallel, unconnected to human narrative. That indifference is its beauty. When the cameras film a creature gliding through the beams, it doesn't react with recognition. It simply continues. It doesn't know we're there, it doesn't need to. And yet, despite the alienness, something familiar lingers in every image. The way a shrimp curls when startled, the way a squid pulses through water, the way small creatures gather near vents for warmth. These are gestures of life we recognize. Movement driven by hunger, fear, reproduction, survival. The basic mechanics are universal. The eyes in the abyss reveal both our difference and our connection. They show that even in a world without sunlight, the logic of living continues. Adapted, slowed, transformed, but never extinguished. What the cameras also reveal, though, is how temporary our vision is. The light fades quickly. The beam illuminates a small space, then disappears into nothing. Beyond that cone, the dark returns, unchanged. It's a humbling metaphor for knowledge itself. The idea that no matter how much we illuminate, the unknown always outweighs what we can see. Each new expedition adds detail, but the outline of mystery remains the same. The deep ocean refuses to become small. In recent years, new kinds of eyes have begun to emerge. Not just cameras, but sensors that perceive the ocean in ways we can't. Some detect magnetic fields. Others listen for chemical signatures or measure bioluminescent flashes automatically, recording when and where they occur. Artificial intelligence now sorts through thousands of hours of footage, identifying species and patterns without human bias. Machines learn to see in our place, finding order where we see chaos. But even as we expand our perception, we remain dependent on interpretation. Machines can recognize, but they cannot wonder. Only we do that. The more we see, the more we confront the boundaries of perception itself. Light, after all, is a shallow phenomenon. It exists near the surface, fades with depth, and disappears beyond a few hundred meters. Sight is a surface sense. The eyes we send into the abyss stretch it unnaturally far, but they can't change its nature. They bring the surface downward rather than bringing the deep upward. In that sense, our cameras are translations, attempts to convert one world's language into another's. Some meanings are lost in translation. Even so, there's something almost sacred about the first moments of playback from a deep-sea camera. Scientists gather around a monitor in a cramped ship's cabin, watching shapes emerge from black. There's a shared stillness as the footage plays. Small gasps, quiet murmurs. It's discovery stripped of spectacle, replaced with respect. The deep doesn't offer revelation, it offers patience. Every second of footage is the result of hours of descent, calibration, waiting. Every glimpse feels earned. And yet, for all our technology, the most profound aspect of seeing the deep remains emotional, not technical. The eyes we've built have become mirrors. They don't just show us the ocean, they show us our need to see. They reveal the persistence of that instinct to reach, to record, to understand. Each expedition is a reaffirmation of curiosity, a statement that even in a world defined by pressure and cold, we're still capable of care. We still want to know. Some of the most striking images from recent years come not from large submersibles, but from small disposable cameras dropped on weighted frames. These freefall devices sink silently, land gently on the seafloor, record for a few hours, then release their ballast and drift back to the surface. They capture life that doesn't even react. Amphipods swarming over a carcass, a snailfish hovering in still water, sediment drifting like smoke. There's no drama, no narrative, just existence continuing as it has for eons. The simplicity is what makes it powerful. The deep doesn't perform, it doesn't need to, and somewhere between those images and our interpretation lies a quiet truth. Seeing the abyss hasn't made it smaller, it's made it larger. Every time we open a new window, we realise how much remains outside the frame. The eyes we've built don't conquer mystery, they expand it. The more detail we see, the more context we lose. The ocean remains vast and we remain temporary. There's a strange intimacy in watching life that doesn't know it's being observed. It reminds us of the distance between perception and experience. The creatures filmed in the deep are unaware of observation, just as the ocean itself is unaware of our awe. The camera's lens is both a bridge and a wall. It connects us to what we could never touch, but it also reminds us that true presence is impossible there. We can see, but we cannot belong. Even so, we keep sending our eyes downward, as if compelled by something older than curiosity, a need to witness the unseen. Maybe it's the same impulse that drove our ancestors to stare at the horizon or look up at the stars. The direction changes, but the longing doesn't. The abyss, like space, represents everything we're not built to inhabit, and that's what makes it irresistible. The eyes in the abyss will keep multiplying. New generations of instruments will see deeper, in higher resolution, across wider spectrums. They'll show us things we can't yet imagine. Organisms with forms we don't have language for, landscapes that rewrite geology, phenomena that redefine life itself. But no matter how advanced the cameras become, they'll always return to the same image in a different form. A beam of light cutting through endless black, illuminating motion for a moment before darkness closes again. It's the same cycle, the same truth. Seeing is temporary, the dark is patient, and somewhere, far below, that patience continues. The slow drift of particles, the steady pulse of unseen creatures, the quiet watch of the ocean itself, unbothered by the eyes that try to find it. The abyss doesn't stare back. It doesn't need to. It already knows that everything that looks into it eventually becomes part of what it sees. For all our effort to reach the depths, we sometimes forget that part of the ocean never left us. It's not only below, it's within. Long before we learned to build submersibles or cameras, before we even had words for exploration, the sea was already here, circulating in our veins, echoing in the chemistry of our cells. Every living creature on land carries a trace of that ancient saltwater world inside. We didn't conquer the ocean, we came from it. The human body is, in its own quiet way, a map of that origin. Our blood contains almost the same balance of sodium, chloride and potassium that filled the Earth's early seas. The proportions aren't coincidence, they're inheritance. The residue of an environment that shaped the first forms of life billions of years ago. Our cells still depend on that same chemistry. using it to send signals, store energy, and maintain balance. When you taste salt on your skin after sweat or tears, it's the ocean reminding you where you began. That connection isn't symbolic, it's biological. Life started in the sea, in conditions that would seem hostile by today's standards, acidic, mineral-rich, unstable. Yet within that chaos, molecules learned to cooperate. Membranes formed, energy flowed, replication began. Every organism alive today is a continuation of that event, modified and multiplied through time but still governed by water. Even our most complex structures, the brain, the heart, the senses, depend on liquid environments to function. We're walking vessels of the same chemistry that fills the abyss. When you look at the ocean, you're looking at the oldest part of yourself. The deep may feel foreign, but it's the foundation of what we are. The rhythms of our bodies echo its movements. Heartbeat like tide, breath like wave. Our sleep follows cycles that align more closely with lunar phases than we care to admit. Even our emotions, calm, turbulence, depth, stillness, borrow their metaphors from the sea. The language of water runs through our description of being human. We talk about drowning in thought, floating in memory, tides of feeling. It's not just poetry, it's recognition. Scientists studying physiology have long noted how finely tuned our systems are to pressure, buoyancy, and salt balance. The fluids inside us maintain equilibrium in ways that mimic the relationship between sea and atmosphere. When divers descend, their blood chemistry shifts to compensate for external pressure. When they rise, it adjusts again, striving for balance. It's as if the body remembers the rules of its birthplace. The ocean outside and the ocean within are governed by the same physics. That memory extends beyond biology. Every civilization, no matter how far from the coast, has kept a relationship with water through rivers, lakes, rains, or myth. Ancient stories of floods, of rebirth through water, of purification and cleansing are not coincidences scattered across cultures. They're echoes of an older truth, that water was our first environment, the medium from which we emerged and to which we instinctively return. Even in the most arid landscapes, people dream of seas. They build wells, channels, and rituals around the idea of flow. The ocean, even unseen, shapes imagination. The connection is so fundamental that it affects how we think and feel. Psychologists have found that being near water, hearing it, seeing it, even imagining it, calms the human mind. It lowers heart rate, reduces anxiety, slows breathing. The effect isn't aesthetic, it's physiological. The brain recognizes water as home. The same frequencies that carry whale songs and the hiss of waves resonate with the frequencies of our own nervous system. It's a conversation older than words, a dialogue between the inner and outer ocean. When astronauts train for space, they do so underwater. It's the closest environment we have to weightlessness. Floating in a diving suit surrounded by water, they rehearse what it means to be untethered, to exist in a medium where every motion requires patience. In a strange way, returning to the ocean is preparation for leaving the planet. Both are exercises in humility. Both remind us that our natural state is one of adaptation, not dominance. And yet, even as we build technology to explore the deep, we often fail to notice how fragile our inner sea has become. The ocean within depends on the ocean without. The salt that flows through our bodies comes from the same cycles that govern global weather and climate. The balance that sustains us mirrors the balance of ecosystems across the planet. When the outer ocean warms, acidifies, or loses oxygen, it's not a distant change. It's a reflection of our own instability. The body and the biosphere are not separate. They are versions of the same system, responding to the same disturbances. Think of the heart as a tide engine. It pushes and pulls, distributing nutrients the way currents distribute heat across the globe. Think of neurons as lightning in a storm, brief electric exchanges that travel through a fluid medium. The boundaries between those metaphors blur because they were never boundaries at all. Every rhythm of life echoes some movement of water. That's why, even without seeing the sea, we sense its moods. Drought makes us restless. Rain makes us reflective. The brain responds to the sound of waves as if to its own pulse. The link is not mystical, it's mechanical, coded into our evolution. The ocean also exists in the way we remember. Memory itself behaves like water, fluid, unstable, reflective. It shifts shape depending on what stirs it, deepens when left undisturbed, distorts when disturbed too often. Our thoughts drift like currents, carrying fragments of past experience that resurface unexpectedly. The metaphor holds because the processes are similar. The mind is not solid, it flows. And in its deepest layers, beneath awareness, something ancient still moves. A collective memory older than culture, shared by all living beings. The memory of having come from the sea. When we look at marine life, we often say it looks alien. But to those creatures, we are the aliens. Air-breathing descendants who left the original world and adapted to another. We evolved lungs instead of gills, bones instead of cartilage, but we never stopped being aquatic at our core. Our embryos still develop in liquid that mirrors seawater. We grow gill-like structures in early stages before they transform into parts of our face and neck. Evolution didn't erase our origin, it concealed it inside us. Every human carries the ocean's blueprint folded into their body. This connection becomes most visible when we confront limits, when the ocean outside reminds us of what we've forgotten. Divers talk about a feeling called immersion calm, a shift that happens once they settle below the surface. The body relaxes, the heart slows, the mind quiets. It's not romanticism, it's biology. Mammals, humans included, have a reflex that activates when submerged. The heart rate drops, blood moves from limbs to vital organs, oxygen use becomes more efficient. It's a remnant of our marine ancestry, a system designed for survival in water that still functions millions of years later. In those moments, the boundary between the inner and outer ocean almost disappears. The body becomes part of the water around it, responding instinctively to its pressure and temperature. There's a sense of returning, not in memory, but in function. The same chemistry that shaped the first life form still guides our reactions. The deep within answers to the deep without. Perhaps that's why being underwater feels both alien and familiar. The weightlessness, the muffled sound, the slowed movement. They strip away the noise of the surface world and leave only sensation. There's no horizon, no direction, no certainty. You breathe carefully, measure each motion. You feel your heartbeat in your ears, steady as a tide. For a moment you stop being a separate thing and start being part of the medium itself. It's not escape, it's recognition. The more we explore the deep, the more we realize that the boundaries between body, planet and ocean are illusions of scale. These same minerals that flow through seawater move through our bloodstream. The same cycles that govern currents govern weather, and by extension, our existence. When we disrupt one, we affect the others. The ocean within reacts to the ocean without, subtly but inevitably. It's not just metaphorical. Salt imbalance, hydration, temperature regulation, all mirror the state of the world we live in. The more unstable the planet's waters become, the more fragile our own systems grow. It's strange to think that something as vast as the sea and something as small as a cell share a conversation, but they do. Evolution linked them permanently. The boundaries of self are porous, and water is the messenger that crosses them. Every drop we drink has passed through countless forms before: cloud, river, ocean, body. The molecules that make us human have circulated through whales, plankton, and ancient rain. The connection isn't poetic, it's factual. We're not beside the ocean, we're continuous with it. Even our cultural evolution reflects that continuity. The rise and fall of civilizations has always followed water. Cities formed near coasts and rivers. Trade, migration, exploration, all depended on tides. Our languages carry the imprint of navigation, current events, streaming thoughts, channels of communication. The metaphors of flow, of depth, of immersion are everywhere because the medium itself defined us. The first technologies, boats, nets, maps, were attempts to manage that relationship. The ocean shaped not only our biology but our behaviour. And yet in our modern world we often act as if we've outgrown it. We drain wetlands, overfish, pollute, and claim ownership of coastlines as though the sea were separate from us. It's easy to forget that the water cycle doesn't recognise borders. What enters the ocean returns through rain. What we release there eventually returns through body. The boundary between the external and internal ocean is temporary. We alter one, we alter both. In that sense, protecting the sea isn't just environmentalism, it's self-preservation. The health of our oceans determines the stability of our climate, our food, our atmosphere, even our DNA. Every breath of oxygen we take owes itself to marine life, the plankton and algae that produce most of the planet's supply. The ocean keeps us alive in ways so fundamental we no longer notice. The air we breathe, the temperature we endure, the water we drink, all are extensions of that same deep body. The ocean doesn't end at the shore. It continues in clouds, in veins, in thought. There's a quiet symmetry to it. The same forces that sculpt the seafloor sculpt our evolution. The same cycles that sustain marine ecosystems sustain civilization. When we look inward and outward, we see the same element, the same persistence. Water connects the smallest molecule to the largest system, the personal to the planetary. It carries memory through matter. It's not a resource to be owned. It's the substance of belonging. Somewhere in that realization lies a kind of humility, the understanding that the ocean isn't just a place to explore, but a presence to acknowledge. It's not foreign, not distant, not other. It's identity. It moves through us whether we notice or not, and in that sense every exploration of the deep is also an exploration of ourselves. When we study the pressure, the currents, the chemistry, we're studying echoes of our own origin story. We're learning what it means to exist in balance with a system older than life itself. So maybe the reason we keep returning to the ocean, in science, in art, in memory, is not just curiosity, it's recognition. We're drawn to it because it feels like remembering something we never consciously knew. The surface world may belong to air and light, but the foundation beneath it, the quiet rhythm that keeps everything alive, still belongs to water. And somewhere inside every one of us, that rhythm continues, the slow, steady pulse of the ocean within, carrying the memory of where we came from, waiting for us to listen closely enough to hear it again.